Well, hey there, my name is Michael Hancock, also known as Crash. I'm the host of the Crashcast podcast. You can find me at thecrashcast.com, where we talk about, well, every week we talk about the radio control hobby, flying airplanes and such, and CNC as it relates to the radio control hobby. This is going to be a little video tutorial series, and we're going to talk about SketchUp, and I'm going to teach you a little bit about, I guess, the basics of using Google's SketchUp for designing your model aircraft and whatever else you want to design. And most importantly, we're going to talk about the workflow that you might use with your models designed in SketchUp to cut the pieces out for those models using your PhlatPrinter CNC machine. So we're going to talk a little bit about that workflow and basically how to start drawing right away in SketchUp, and then how to apply, I guess, parameters to cut out the parts and be able to send a machine code called the PhlatCode right on over to your PhlatPrinter CNC. First off, let me say I cannot take any credit for this because, well, I didn't develop any of this. I'm just a bit of a hack myself, but I've learned how to use this workflow, and I've learned it from, well, the Flat Boys themselves. I've learned it from various other contributors over at flatforum.com. So I'm just trying to pull some of the basic pieces of information together that you need to get started right away. Hopefully when you've completed watching this series, you'll have a pretty good grasp on how to use SketchUp and then start developing your own skills. Speaking of Flat Boys, I just have to talk about this. Maybe you're watching this because you've just purchased a PhlatPrinter CNC. I have to say, these guys have totally revolutionized the CNC hobby. Before CNC machines, routers or lasers or plasma cutters or whatever, those were all items, pieces of equipment that were way out of the price range of any hobbyist by far. Well, along come the Flat Boys and develop CNC routers in a small footprint that are not only small, they're very easy to use and very accurate, very robust, and super inexpensive pieces of equipment. And if it hadn't been for them, well, I wouldn't be here today, I'm sure. Not with this information. So my hat's off to the Flat Boys, and hopefully if you've not ever heard of a flat printer, well, then you need to go check them out at flatboys.com. First off, in this series, I guess probably one of the most important things for us to discuss is, with efficient workflows and getting everything set up and learning to use the stuff, learning to use this cool software, I have to say file management is of the utmost importance. When I talk about this, I don't take it lightly. I come from a background in the graphics packaging industry where I dealt with terabytes of data on a regular basis, and file management is very important. And I would urge you to try to follow some of the cues that I'm going to give you here just to make your own life a little easier. This is a good place to start. I've got a little template that I make for every new project that I do, and we'll talk about it here. This is my new project template, and I use this for pretty much every project that I work up. In here, you're going to find 3 folders. My images folder, and that's going to be where I keep images that maybe they're bitmaps or JPEGs or GIFs or a host of different image type files that I may be working up a new concept based upon. That can include 3 views, photographs, what have you. As well, in this images folder, I also like to place in screen captures of my finished product after I've worked up a design, and then I go ahead and render it in 3D so that anybody looking at it can say, oh, I recognize that. Well, when I'm finished with that, I will often upload a screen capture into my images folder there for the particular project. That's also useful because I can go back later after working on hundreds of designs. I can go back later and say, oh, that's the airplane that I want, and that little thumbnail image is going to help me to find that. The next folder down you see is called PhlatCode. Now that's where I'm going to put, well, my gCode. PhlatCode is the name given to gCode, which is machine code, instructional PhlatCode information that's generated from the FlatScript plugin. And that's part of the Flatboys CNC solution. And that's where I put my final output codes that are going to go to my CNC machine when I'm ready to process that file. And then finally in the folder is my SketchUp folder. And I have a SketchUp folder for everything, every project that I do. And inside the SketchUp folder for a particular project, you're usually going to find, my source file. Maybe I'm working on something like an old-timer design, a Lanzo bomber. And once I have that whole airplane worked up and everything's ready to go, I save that. Well, I save it many times along the way, but the final project that I save is going to be a SketchUp file for that with the 3D rendering and all the two-dimensional parts ready to cut out. And then secondarily, I'll have another SketchUp file that'll often be, that same name, but it'll say, underscore with codes. After I try to keep my coded, you'll understand more about this as we go, but my coded file, I try to keep that as a separate file from my original. That way, if I ever want to make changes, I don't risk maybe coding a project and then making some big horrendous mistake and then losing my original information. I just keep them separate. So those are the files that you'll find in the SketchUp folder. And I guess with that being said, we are ready to start. You're going to install Google SketchUp 8 right now is the latest version that I'm using. Okay, the first place we want to get started at is the installation of Google SketchUp. Now, I'm going to show you, in these exercises, we're going to use the latest version of Google, which is version 8. Now, if I open up my browser and I head on over to sketchup.google.com, it's going to take us to this website that you see. And from here, you can go over to the left-hand side of the page and click on Downloads. And we have an opportunity here to download Google SketchUp 8. Now you see here there's two options here. We can either download Google SketchUp or we can go over here to download Google SketchUp Pro. This version is going to cost you. We want to use the free version because in our design work for our models and using the FlhatScript to create our CNC files and so forth, the free version of SketchUp is all we need. So simply click on this button here and it's going to give you the opportunity to download the free version of Google SketchUp. And that's what I have here on my desktop right here. And I've already installed Google SketchUp. I'm not going to waste your time and DVD space to show you how to install it. Just double click on the installer file after you've downloaded it and just go through the wizard and it'll show you how to install that application. Now before you open that application, once it's all installed, everything's finished, don't launch the application, because what we're going to do next is we're going to install the 3 most basic plugins that are required for all the exercises contained here in this DVD. Now I'll show you, you can go to, opening my browser again, you can go to my favorite site, flatforum.com, and this is a place where you can get tons of information and anything regarding Google SketchUp and the design of models. But if we scroll down to here, you can actually download version, I believe it's 7.0 of Google SketchUp right here. And a lot of the guys are using Google SketchUp 7. Because this is intended as an instructional and I want it to last, for a few years, we're going to go ahead and use the latest version, which is SketchUp 8. But that's where you could get it. Furthermore, I'm going back to the main page. You can get into this FlhatScript section, and this is where you can download the FlhatScript, and periodically there are new versions released with more features, and this is where you would come to get it. And you can also go to other things. I'm going to click on PhlatScript related software, and you can see some things here. Here's a sprocket creator and the gCode plotting plugin and so forth. There are also other things, PhlatScript tutorials. These are some videos that have been done. But what I've done to show you here, we've got other SketchUp related softwares and plugins. If we go here, then you'll see there are just many entries here, many posts in this particular portion of the forum, and these are all plugins that people are using. So SketchUp has a lot of expansion capability. Now, I use this term plugin, and you're probably wondering, just what is a plugin, Crash? Well, a plugin is, consider it a very, very small program that runs within the program Google SketchUp. Google SketchUp was designed with a specific list of functions and features, but because it's based on a Ruby script platform, a particular language, we can create our own smaller applications that can run from within Google SketchUp and allow us to do a host of other things that were not included in the original version of SketchUp. And here we can get lots of things. We can take SketchUp files and convert them to STL files, gears, plugin. There's just a whole lot of different plugins here. We're going to be using 3 plugins in this exercise. We're going to be using gPlot, we're going to be using Weld, and of course we're going to use the all-important Flatboy's PhlatScript. Now, to make your life easier, rather than trying to have you look all over this site to get the specific plugins that we're going to use, if you go to my podcast support site, and this site is allthingscrash.com. If you go here and on the left-hand side in the main menu area, you can come to Downloads. And if you look in the Miscellaneous folder, click on that, you can see that I have included here a archive file in zip format. It's 1.7 megabytes in size, so it's a pretty small file. It'll download very quickly. I've put in here the 3 plugins that we are going to use in this DVD tutorial. And if you want to click on this, you can click to the right-hand side in the checkbox, scroll down and hit the Continue button. And now all you have to do in this next screen is just hit Download, and you'll be able to download this file package. And I've just tried to make it easier for you. One location, and you can grab the plugins package for this DVD tutorial. We'll close that. So now we've installed Google SketchUp from our downloaded installer file, and now we've downloaded the plugins from my website. And again, you can get these at Flat Forum along with all other things, but I just try to bring them together in one easy to find location. Well, once we decompress this archive folder, we get these items here. And I'm going to scrunch it all up so you can see it best. And here's our 3 plugins. We've got Weld, we've got the PhlatScript, and we've got gPlot 1.3. These are what I consider, again, to be the 3 most elemental, most basic plugins that you should download and use to make your version of Google SketchUp, I guess, do all the things that we're going to do here in this tutorial. So now we need to install these plugins. Well, when you installed Google SketchUp, it deposited files on your hard drive for that program, and we've got to locate those. Now, I can tell you I'm on a Windows Vista machine. So if I come down here to Start, and I come over here to Computer, I get a list of all of my, categories here on my hard drive. If I go to my C drive, my root drive, and then I come down to Program Files X386. That's where all my program my application files are stored. So I'm going to double click Program Files X386. It may be different on your computer, but this is how it does in Vista on my machine. Now we're going to look for the Google folder, and here it is right here. We'll double click, and there's Google SketchUp 8. Now you'll also notice I have 7 in here, but again, going into the future, 8 is the latest release, so that's what we're working with. If I double click on SketchUp 8, now we get all the program files for this particular application. The first thing we're going to do is let's go to our plugins folder. And that's this guy right here. We're going to enter this. We see that there are some files already here. Well, in this plugins folder, we're going to come over here to gPlot. We're just going to double click on this folder, and we're going to grab these 3 files for our gPlot plugin, and we're going to slide them in here, just like this. Okay, easy enough. We can back up, and we'll back this one up. Now the next one we're going to do is our tools folder right here. We're going to open this one, and I'm going to open up on my downloaded files here, my PhlatScript folder, and I'm going to open up my tools folder, and I'm going to grab these files in this one folder just like this, got both of them selected, and I'm going to drag them right over here into the tools folder, and there they are. Now while we're here in this tools folder, let's go ahead and grab our Weld tool. We're going to drag this guy over here too. Now we've only got to do one more thing. We're going to go into the resources folder of our SketchUp 8 installation, and we're going to go ahead and enter into this English US folder, and we see that there are already files there naturally. We're going to go back into our downloaded PhlatScript, and we're going to go into our resources here, and we're going to open up this English US folder, and we have a file in a folder here. We're going to grab both of these, and we're going to move them into this English US folder under the resources, and naturally there's already a templates folder. We're just going to override it. So say yes, and now we're done. That is the installation of your plugins that we're going to use in this exercise. We can close these 2 windows. At this point, we're done with these files, so we may delete them. And now we're ready to start Google SketchUp. And I'm going to launch SketchUp 8. Now the first time that you launch, you're going to be given an opportunity to select your template and all that. I go over here and I say always show on startup. I'm going to uncheck that. And we have to choose a template, and I'm just going to use the beginning training template inches. We'll start there. And now we're going to start using SketchUp. Now it is time for us to set up some toolbars. I'm going to close off this instructor. Pretty useful tool, but since we're using SketchUp primarily for preparation of files for CNC, and we're using them for the model airplane industry, we're not using it for buildings and bridges and so forth, so I just don't use this. Now we're going to start off by, again, setting up toolbars. And we should be able to go to View, Toolbars, and we'll go to the large tool set. That sets us up pretty good here. Now we're going to do some additional tools. Let's go to, what I like to do here usually is I'll just go and load pretty much all the toolbars. And let's see, View, Toolbars, Construction, that's a duplicate. Solid, drawing, styles. We're going to clean this up in a moment. I don't use the Google, I use layers. Toolbars. Measurements. View. Principle we need. Looks like some of this stuff is duplicated, and that's okay. We're just going to clean it up after we get everything loaded that we want. I'm going to have the Flatboys tool set, and it wants to drop it out here, just out in the middle, so we're going to put that up in the toolbar temporarily. Continue on. Let's see, modification. Basically, again, I'm just loading all the toolbars. I know I don't need shadows. Standard, we'll put that in. I don't use walkthrough. I do use views. And I think that's enough to get us started here. Now, we don't need two of these, so if I just click on a blank space and drag this out, where I click right there and drag it out, I can delete it. I'm not really deleting it, I'm closing it. And this one I don't use. I can never remember the names of the tools that I use and I don't use, so I end up usually just dragging them all out on a new installation, pull them all out, and then I get rid of them. And let's see. Now up here, I don't need layers. That's more of an advanced thing that we can use at a later date. And there we go. Should have done that to begin with. Delete the getting started one. All right, well, now I have my file dialog open, close, save, all that mess. I've got my views. I've got, these are our transparency views. I think we pretty well got it all. So anyway, we've got everything set up. This is the way I like to set mine up. You can do it any way you want to, naturally. There's one more thing we're going to do. We're going to go down here to the bottom, and this is our measurement tool. I like to drag that up here to the top. Just makes it easier. Now you can set up these toolbars any way you like. These are the most used toolbars for me. I use SketchUp since it's a free program. I will install it oftentimes on many machines, and if I set all my toolbars up the way I'm used to seeing them, then I can hop from machine to machine. I think right now I have it on 4 different machines. So it just makes it easy. There's no sense in, saying, where is that icon? You get into such an automatic workflow. You just know where to go, and if a toolbar is not there, then it slows you down. It makes you less efficient. And I guess the next thing for us to do is to set up our template. It may be a little difficult for you to see as you're watching these instructionals on your screen, whether it's a television or your computer screen or whatever, but when I look at the current view that we have right now, there's a couple of things as an experienced SketchUp user I can see what's going on here. First off, I see everything below this red horizontal plane I see is all white, and above that red horizontal plane I'm seeing a vignetted white to light blue. That tells me a couple of things. The first thing it tells me is that I'm looking at this from a side view. So I can come up here to this button here, which is, these are our, I guess, our perspective displays, how we want to view our model. This one gives us a perspective 3-dimensional view. This gives us a top-down view, a front, let's see, a right side, a back, and a left side. If I click on the top, I can see everything is all white. And I want to talk about that for just a moment because I want to elaborate on this. When the way I work in SketchUp, I've got a graphics background, so I am all about working in 2 dimensions. But SketchUp allows us to see things in 3 dimensions. Well, I find the easiest way to get into design work is to consider everything in a 2 dimension and then work in 3 dimension. In other words, my current skill set doesn't allow me to, I guess, real effectively design in 3D and then tear it down to 2 dimension. So I work 2 dimension and then assemble into 3 dimension. The more, I guess, experienced designers, they'll work in 3 dimensions all day long and then tear down. I'm not there yet, and as beginners, you guys won't be either. So we're going to talk about a 2-dimensional to 3-dimensional workflow. Now, the top-down view is the view that you're going to be using quite often. Because if you think about it, you know, if you were doing this old school, you were designing your model aircraft the old way, well, you'd pull out a sheet of paper and you'd lay it on your table, either your dining table or your drafting table, wherever you work, and you'd immediately start sketching. Well, this view, consider this rooftop view looking top down to your desktop, to your, you know, physical place where you get your ruler and your pencil and your calculator and everything else. That's going to be very, very important. With that, in this side view, I want to go ahead and make a few changes. Now, you don't have to do this, but this is the way most of us in the Flat Club of PhlatPrinter owners that are using SketchUp to create models to cut out on their PhlatPrinter CNCs, most of us follow this route. And I'm going to show you. This is considering side view. This is the sky. This is the ground. I want to change it so that everything is white. And I'm going to do that by going to Window. I'm going to go to Styles. And I've got the Edit tab here. I'm just going to click off of Sky. And now everything is white. This is, I guess, more of a drafting engineering type mode where we don't need to see, you know, the sky and the background and, you know, the terrain. We don't need to see all of that stuff. Now, as you move forward and you want to, you know, assemble a 2-dimensional model into a 3D model and then show it off to the world, you may wish to turn these things back on. But for the designing purpose, I don't use it, and I'm going to show you how to not use it. So I've simply turned off the sky. I've made sure the ground is turned off, and we're pretty good with that. As well, we're going to play with our template a little bit. Now, SketchUp is cool in the fact that whatever template that you worked on last, it's going to remember that, and it's always going to draw up on that. So I'm going to show you how I like to work. Now, if we go into Window, Preferences, one of the things that we can come to here is our template. And we can select from a number of templates that SketchUp provides. We've even got our Flatboys template in there. And that's a great template. I'm going to go ahead and load it. I choose not to use it. For me to load it, it would have to be, I can see that it would have to be restarted for it to show. I don't use it because what it does is over here in the lower right hand corner, it shows the Flatboys bug, and it basically, that's a good template for uploading your 3-dimensional rendering and all if you want to share your model with the rest of the Flat Club over at Flat Forum. I personally don't use it because I've got my own personal template that I like to use. But anyway, if we go back to Window, Preferences, we're on Templates, we can go back to this last one here. And eventually we're going to create our own template. So we will get into that. Let's talk a little bit about system preferences. I don't use a default image editor. If you had one that you wanted to use to edit your images, you could. I don't bother with that. Compatibility, I don't bother with. Drawing, I use auto detect under the click style, and that's the only thing I have there selected. Extensions, files, this is more advanced things here, selections and options and stuff. We're not going to bother with using that right now. General, I choose, this is going to come default to create a backup. and it's going to also auto-save every 5 minutes. Well, I've changed mine. I don't create a backup file because it's going to give you, let's see, it'll give you a SketchUp file, and then it'll give you a backup file. I use very robust computers, and I haven't ever had a situation where I've crashed and had to go back and work from a backup. I save my work often and so forth. So I don't use it because that extra file I find to be kind of confusing. But I do have autosave on, and I let it autosave every 3 minutes. That's just what I do. And let's see here, shortcuts. Shortcuts are great because you can assign hotkeys to any of these tools. I did that a lot when I used Illustrator in the graphic packaging days and graphic design work. I have not taken the time to do hotkeys on this application yet. I probably will eventually. And if you are comfortable with hotkeys, you might ease into that by creating a hotkey for maybe one tool and then get used to that and then add them and so forth. But I'll leave that up to you. Again, there's our template, workspace. Use large tool buttons. That's what I'm doing. I find that I'm kind of clumsy with a mouse on the keyboard, so I just use the large tool buttons. If I deselected that, they would get smaller. Totally up to you. It might help you to save some real estate on your screen display. And we've got just this beginning template we're going to continue to use. We're going to make some changes though. Window, let's see, model info is a good place to start. I'm not worried about animation or components. Credits, if you wanted to put in a credit here and claim credit for your own design, and then maybe you want to upload that to the Google 3D warehouse, well then that file through metadata will always contain your information as you being the author. I don't bother with it. Dimensions. Here's where we set our default text and so forth. And I'm leaving these things at default. Geolocation, I don't bother with that. Rendering, use anti-alias textures. If you're having problem getting a rendering out and seeing everything on screen properly, you might try unchecking that or go back and recheck it, whatever. Statistics, that tells you that's model information, what all is in this file. Text, I'm using the default. In my case, it's Tahoma 12 point. And then finally, units. Now here's where I'm going to make some changes. I like to work primarily in inches. We are in America here where I am, so I like to use inches. But I always use decimal. Now, how precise do you want it to be? This is your opportunity to check it. I use 4 decimal places because for my work, that will pretty much allow me everything that I need. I don't enable any snapping. Now, sometimes you may decide you want it to snap, and you can say how, to what degree, how sensitive it is to snapping, but I don't use that. And then your precision, and I pretty much just leave that alone. So we've got a model template now. We've got, let's tell you, I'm going to change our camera. You see on the display here, you're probably seeing, we're seeing this from a side view. Let's go to a top view. But if I use my orbit tool and rotate it out, I can see this blue line here. When we're working primarily in 2 dimensions, we don't want to see that. We always want to be looking straight down onto our work. And this tells me that we have our camera set at a perspective view. So I'm actually going to go back and change that. I'm going to go to camera, and I'm going to change that to parallel projection. And then when I go back to my top-down view, no matter how, I can use my hand here. That's our pan tool. No matter how I pan, we're always going to be looking straight down 90 degrees to our work surface. So that's the way I'm going to urge you to work in 2 dimensions, is always set your camera to parallel projection. Set your background like we've done through styles, so that your background is always, the ground is always white, the sky is always white. It just takes out, in my opinion, it makes everything simpler. We've got our unit set. We are in inches right now. With that, we've got everything set up like I think we should have. So hey, let's save this as a template. See, I have this option here under File pull down. I can save as template, and it's going to ask me, hey, what do you want to call this? And I'm going to call it Crash Template. And I can give a description here so that it shows up in the templates dialog, and I'm going to say all white. I'll say inches to 4 decimals, and I guess that's it. And that will give me enough to know that this is what I'm working with, and I'll save that. And I had the checkbox there. I moved too fast, but I had that set as my default template. So now if I were to close up SketchUp and I open up SketchUp again, it's going to be on that template. I can double check that by looking at, well, we can already see, but I can look at my model info and see that I'm decimal, inches, 4 decimal places. And if I were to go to my styles, there you are, I can go to edit and I can see that sky and ground are unchecked. So this is a good starting point. We've laid out our toolbars. We've installed our plugins, installed the program, we've got our template set up, and all is good. Incidentally, if we want to look at templates, I should be able to go down to, what was it, Window, Preferences, and I go to Templates, and oh, there is Crash's template. So, now we're ready to start getting into the next part of this instructional. In an effort to try to perhaps ease you into the use of SketchUp, we're going to go kind of slow here, and we're going to build some basic skills. The first thing we're going to talk about is basic drawing. Now, I guess the best place to start, easy enough, is with our pencil tool. And our pencil tool is going to allow us to simply left click on your mouse button, and you don't have to hold it, and then you're going to draw out a line, and you can draw and then click again to stop. We can go up, we can go, let's go at an angle. It may be difficult for you to see on the screen here, but let's say I wanted to make this line the exact same as this bottom line here. Well, if I come up and I touch that pencil right there on the end point of that line segment, and then go straight up, you'll see, and you may not see it very well in this view on your display watching this instructional, but I've got a dotted green line, and that basically tells me that I am currently straight above that, 90 degrees above that line. So if I click now and I come down, I've made a rectangle where these two sides are the exact same length as one another, and this side are equal lengths. So that's a useful tool. When you're drawing fast, sometimes you'll say, oh, it's not giving it to me, it's not working. Well, if I incidentally, let's say I want to make another figure, another shape, and I want it to start at the same point. You may see here there's, and I don't know if you're going to be able to see it on your display, but I'm getting another green dotted line there. So if I click and I go over, I'm getting a reference point to this one. And you see how my line, I haven't clicked yet to draw this, to complete the drawing of this line segment, but you see how it's red in color. And if you trace down here, we see this is the red plane, which is our x-axis. That's why that line is red. So I can click, and then maybe I want to draw a bigger one, so I'm going to go up, and now that line is green. And you may say, well, why is that line green? Well, that is in reference to the y-axis here. So it's going to be green. And I can click, and I'll come out, and I can come down here to that line segment, hold it for a little bit, and then come up, click, and then come down, click. Now I know in this little exercise that this shape, although this axis, this length is different than this one, I do know that this segment here is the exact same as this in length. So it's just nice little tools that you can see to use. Now, one thing I want to show you real quick, I'm going to go back to my direct select tool. One thing I want to show you, and this may be bothersome to you, these lines look a little bold to me. So if I come over here to my view, and I come over here to edge style, and I take off, I uncheck profiles, then I lose that real thick bold line. So something that you might decide that you want to do from time to time if you don't want to see those real thick line styles, line weights, that's a way to get rid of that. Something that also I'd like to show you. If I take my direct selection tool, I don't really see it here. I can select a line. Maybe I want to move that line or delete that line altogether. I come over here with, well, while it's highlighted with my direct selection tool, if I simply hit delete, then that line segment is gone. Now, what did we see happen here? We have this shape here that has a blue, we call it a face. It has a blue face on it. This one doesn't. Well, a blue face is going to indicate to us that we have a closed loop path. In other words, all of these line segments are all connected. They're all intersecting, and that gives us a planar face, is what it would be called. Now, we deleted a line segment here, so we don't have that. But because we don't have a closed loop, and to get that face back, we just close the loop. That's something that I wanted to show you. Now, while I have this drawing tool, there's a neat thing that SketchUp allows here. Sometimes I want to find the exact center of a line segment. And if I take and just put my tool on there, or my pencil tool on there, you'll see that I've got a little red dot, but as I slowly trace down, now that dot is snapped in and turned, this bluish greenish color, and that tells me I'm at the midpoint of a line. And that's something that you can use to your advantage in drawing and assembling your three-dimensional models. So if I wanted to draw a line out as such, then I could. Now let's say that all I wanted was that one line. Maybe I'm making a reference mark to be used later in my drawing. Well, my pencil tool is, stuck on there. I could go back to my direct selection tool and then select my pencil tool again to do something over here like that. Or what I could do is just simply hit my escape button. And I'm going to hit it right now, escape. Now I've still got my pencil tool and I'm ready to draw maybe some other figure. You can see. Now, once I intersect two lines like I've done here, well then I'm not dragging out another line to worry with. Once a loop is closed, then it considers that line segment to be complete and it doesn't drag out further. I could do it again. See, I'm got the line. I can come over here and click. I've closed a loop, so my pencil tool is not dragging out a line looking for the next coordinate in that line segment. So just things to show you there. Here's my eraser tool. And if I select that, I can delete any line that I want just by clicking on that line and tapping my left mouse button. So those are just some real basic concepts. Now let's go into a little bit more depth. Let's say, what size is this shape that I've made? Well, I can take this tool, the dimension tool. If I click on it, I can click on the edge of one line segment, and then I can come over here to the edge of the next line segment, and I can click again, and then I can pull up or down, whichever way I want to, and then click a third time. And now I have a measurement in there to show me for reference. That's kind of cool. Now right now, maybe I don't want to work at almost 97 inches in length. Maybe I want to say, hey man, this model needs to be a different size. Here's a cool trick that I'm going to show you. Let's say we want to bring this down to just arbitrarily 20 inches. I take my tape measure tool and I click on it, and I can click this line segment and then this line segment, and then now without doing anything else, I'm going to type in 20, And you can see that over here in this length box where I typed in 20. I hit enter. And it didn't do it. Let's try it again. I moved the mouse, that's the reason. But I click and I say 20 and enter. And I get this dialog, do you want to resize the model? And in this case, I'm going to say yes. And in doing so, you can see here, I have resized it all the way down. Now this dimension is correct at 20 inches. So it's going to be pretty useful. Let's say you've got an airplane that you've drawn up and you're really pleased with the performance, but you say, hey man, this 28-inch wingspan aircraft, imagine how it would be at 36 inches. Well, because this will allow you to scale the entire model proportionally and all elements in your drawing, then you can select a wingspan of a model and then scale it up or down to anything you need. Something that's very, very useful. That's one of the first tools that I found to be terribly, terribly useful. Now maybe I want to delete my measurement reference, and I can do that by using my eraser tool, or I could have selected it, either a marquee selection as such, or I could have, selected it just with the direct select tool and hit delete. Either way, that would have achieved the same end result. We have other tools here. This is our tool for drawing squares. Incidentally, I can zoom in and out. I'm using a mouse with a wheel button, and when you have a mouse like that, SketchUp already knows that by running that scroll back and forth that it wants you to zoom with it. So I use that to manipulate around the screen. Now I can draw a square, and you see, let's see, I've got a reference there. I can do, I'm getting what would I call that? The dotted line that's going from opposite corners. You'll see I've got a rectangle there, and I've got it, if I keep going down, well, now I've got another line there. And these are representing degrees. I have SketchUp right now currently configured to snap in 15-degree increments, and I can show you that. Well, here I know that this is based upon a 15 degree. There's another should be popping in here somewhere. Anyway, if you don't like that, you can change that. I like it because it helps me to make true squares, but the way that you turn that off is to go to Window, is it Preferences, and I'm sorry, that is incorrect. Window, Model Info, Units, and I can disable angle snapping. And if I try that again, I will only get it on the 90 degree or the 45 degree to help me to make accurate squares. And that's just a tool that you may find useful down the line. Now I've got a shape started, a four-sided shape. If I just simply say, "Oop, I'm not going to do that," hit my escape button and it's gone. So that's how we draw accurate rectangles and squares. Now what if we want to draw a circle? That's our circle tool that I'm selecting. And basically what I can do is I can click once, I can drag out. Now let's say I have a circle that I want to have a 1-inch diameter. Well, you can see from your display here with that little red line that's referencing, I have, if you look over here, I want to take it away, it's real big, but if you look at my radius here in my measurement toolbox, that is going to tell us the size of that radius. So if I wanted, let's say, a 1-inch, then I could just simply, without clicking a second time, I can type in 0.5, hit enter, and now I have a circle with a true 1-inch diameter and a 1/2-inch radius. It's just a real quick way if you want to make precision circles. If you say, I need a circle and I need it to be this size, well, that's how you can do it. Furthering basic drawing skills, we have our triangle tool, which is, it shows as a triangle, it's a polygon, but it will get you to triangles if you need it or if you want to do polygons. This is a free draw tool. I've not had to use it for anything. I suppose I could, but I click and just hold down, and I can draw some sort of free shape. And that's what we get. But for the kind of work that I do, I can't say that I've ever needed that. But now let's say, maybe I'm going to select all of that and delete it. I just highlighted it with marquee and hit the delete button. Let's say that the shape that I had intended to do here, I needed it based on a square, but I needed a circular shape on the outside. What I could do is, I can either highlight that and delete it, or I can use my eraser tool and delete it. But now I can use this tool, which is my arc tool, and I can click on that end line segment, and I can come over here and click on that end, and now I have the ability to stretch this out to whatever I need it to be. And it's going to want to default on a semicircle. It should, I guess without degrees it won't snap, but I could pull that out to whatever shape I want, and that might be good for making a firewall with a turtle deck. Maybe I want to come by and make one on the bottom here too. Well, there's a couple of things I could do. If I want it to be symmetrical, I can grab that shape, I can copy it. Now there's two ways of copying it. I can either hit Control C and Control V and it will give it to me, or I can also copy it by using this Move tool. These arrows right here are our Move tools. So if I click on that while this is highlighted, now I can move this completely away from the design. Well, it's going to bring these lines with it as well, because those endpoints of these line segments are still attached. But if I hit my Control key once, you'll see a plus come up. So now I can move it completely away, and it's separate from these vertical line segments. So that's kind of an interesting thing. Now, going into a little bit more advanced, maybe I want to take this exact same shape, which is the exact same as this one. Maybe I want to rotate that so I can bring it to the bottom. Here's a cool trick. You can use your rotate tool. If I click on that, and then I click anywhere on this line segment, in this case I'm going to go here, click once. I want to pull it out on the horizontal plane, which is our red axis. It's not really horizontal, it's the x-axis, but it looks horizontal because we're working from a top-down view. If I click again, now I can rotate this thing around and it'll snap. There it goes. It'll snap to that red axis to give me a full 180-degree rotation. Click again, and now I can grab my Move tool again, and I want to grab maybe this line segment right here, right at the end of the arc, and I can bring it down. I'm going to zoom in as I do it, and if I put it right there, right on that end, and I click, well, now it's attached. Now, but you're saying, well, gosh, it looks right, but you don't have a face. That's a thing that SketchUp does. Sometimes it's useful, sometimes it's not. But if I wanted to take my Draw tool again, my pencil tool, and grab just any line segment, I could do it from here to here, or I can zoom in. You'll see that SketchUp defaults to a less than nice arc. So I could click on here and just redraw this line segment, and now we've got a face, which tells me that I accurately brought this bottom arc into place and it actually closed the loop properly like I wanted to. So those are a few of the tools that tells us, some basic drawing and erasing and editing. And these, the fact that we can work with squares, we can work with rectangles, we can set the scale to be any line length being the length that we want, like I showed you by taking your tool, click once, draw, maybe say, 2 for 2 inches, hit enter. Now we've got a 2-inch line. If I, wanted to make another 2-inch line, I just stretch it up. I don't click. I hit 2 and enter. Now I've got the basic of I can start making a 2-inch square or an isosceles triangle, either way. So those are tools that you can use. You can use what you know to very easily and quickly, work up shapes and designs and wings and so forth. And I guess with that, we've got the basis of drawing and measuring and scaling, and this looks like a good place to stop. Well, with the basic drawing skills that I've shown you during our last session, believe it or not, you now have it in your hands, capable, or the capability, to create your own parts for aircraft and be able to cut them out on your PhlatPrinter CNC. Now you're asking yourself probably, well, wait a minute, how can I know that? Well, if you find an airplane that you really like, or maybe you've got one in your hangar that's beat all up and you'd really like to have another one but don't want to buy another kit, well, then you can take the time to pull dimensions off. If you're not going to design an aircraft from scratch, like, many of us designers do, maybe you want to mimic something else. You know that this wing area and this fuselage and this size, they all work really good. Well, with a tape measure and a notepad, you can take enough information off that model to be able to work up your own rendition of that that'll fly just as good. Now, there are other ways, and incidentally, that proves really good. Maybe you're out, you found somebody else that's got a scratch-built airplane, and you're really digging on it, and you say, I'd like to have that. Well, with a little bit of planning, a little bit of, measuring and drawing and sketching out, you can come back with the data to sit down at your computer, open up SketchUp, and start mimicking that airplane. Now, if maybe you've been to a fun fly and you've taken a picture of something that you really like. Wow, that airplane's got nice lines. Or I saw a full-scale Extra 260 at a full-scale air show. Take some good pictures and you can mimic that yourself. Just get good top-down views, which is going to be impossible on a full-scale airplane, but it's a good side views. You can work all of this information up. Now, you're asking probably how, With SketchUp, you have the ability to import images right into the program so that you can work them up and get pretty much what you need designed. Furthermore, on the internet, because we live in this new modern age that offers us so much with the internet, you can download 3 views, which are just graphic images, 3 views of pretty much any airplane out there. And I've used that many, many times to work up something that I thought was a really cool airplane and put it into modeling terms. Now, I'm not going to, although SketchUp is very capable of working up a full 3-dimensional fuselage, rounded, pretty much anything you want, because I'm aiming this tutorial series at beginners, we're going to start off with what I call flat plate foamies. We're not going to deal with airfoils, we're not going to deal with bulbous fuselages and so forth. We're just going to deal with, real basic stuff. As your skills increase, you'll be able to do more and more with it. But we have to have a place to start, right? Well, I hit the internet and I found something that I liked. I just grabbed a 3 view, found it on Google Images, and we're going to import that in. Now, we don't hit open with our fresh SketchUp document. We're going to hit import. And SketchUp is going to allow us to import various image files, from Photoshop documents to PNGs, JPEGs, pretty much any kind of image file. Now, it's a shame because Google SketchUp used to allow us the capability of import of DWG and DXF files, but that ceased after, I guess, version, I want to say 7.1 was the first version of SketchUp that knocked that capability away. Now, if you really get good at SketchUp and you want to buy the professional version, and I don't know what it costs, but that pro version will allow you to deal in DXF. And there are lots of DXFs out on the internet that will allow you to import other people's work and then use them as you want to. But we're not going to get into that because the new version of SketchUp doesn't allow us to. So we're going to deal with some image types. Now, I'm using all supported images, and I'm going to be able to see on my desktop this one that I just downloaded. And there it is. Now, I haven't moved my mouse. I want to warn you something real quick. When you import an image, it's going to let you position that image anywhere you want to. But if you click it a second time, it's going to scale that image. And oftentimes you would rather work with an image at its original size rather than, something really large or really small. So I'm going to suggest that what you do is when you get the thing positioned where you'd like to see it, click twice. because clicking once places it, and then anywhere you move your mouse after that, it becomes it starts to scale it. So go ahead and click twice, and now we've got an image. Now, before I go any further, I'm going to take the opportunity to save my work. This is open source software, and sometimes, that is a Bearcat, sometimes it likes to be a little picky on us. It likes to crash and all, so we're just going to save our work, especially when you're dealing with image files like this. So now we've got our file saved. Now, basically all that's left to do is lock this image. Now, because it's an image, you're not going to be able to lock it. I'm going to show you a trick though. And the reason I say we want to lock it is because we don't want to risk moving it along with the rest of our work as we're moving files in and out. So the way we're going to get away from that is we're going to right click on it. Once we have it selected, we're going to hit explode. Now when I select it all again, we can see we've got a face and we've got the sides of the bounding box and so forth. If we right click again, we make it a component, which is basically a grouped element. So I'll say create. And now, when I select it all, we have one component. Now, if I right-click, I can lock this file now. And we're not going to do that yet, because first thing I want to do is, I'm not going to build this entire aircraft, or redesign this entire aircraft for you. I just want to show you some of the skills that you can do so you can go about this yourself. If I tried to do it myself for you, then we would probably end up with a 4-hour video series, me trying to explain every motion. So I'm going to just do the highlights. It would be very easy to trace this off. It'd be very easy to do this one. Because we're doing a flat plate foamy, these are the only two portions of the image that we're going to use. And because I'm not going to do the whole thing, I'm only going to use this one. Now the reason I'm going to use this one is because I want to show you how you can move it to help you draw straight lines. Now in this case, this is on an angle, like so many 3 views are. They are shot on angles. So what I'm going to do is try to use information that we have within our document already to square things up. And what I'm going to do is I'm going to grab my move tool, which is this tool here. Also M on the keyboard is a built-in SketchUp shortcut. I'm going to bring my crosshairs to about, we're going to say right at about the middle of that piece there. We'll zoom out, and then let's bring it right here onto our y-axis reference. If I zoom in, I'll be able to see right there. Now, we're still crooked, of course, but what we're going to do is we're going to grab our rotate tool, and we're going to put our first point of reference with the rotate right at, we're going to feel is about the middle of that. And honestly, I'm just going to put it on the line there. It looks pretty good. Now we zoom out, and we're going to stretch this line up to what we feel is pretty good, pretty close to halfway down this fuselage. I'm going to make a reference mark. Click, and now we're going to rotate it to the vertical plane, and that looked like it did a pretty good job. I'm pretty happy with that. Now, since we have this where we're about ready to work on it, I feel good about that. We're going to select this entire component, we're going to right click it, and we're going to lock it. Now, no matter what happens, we don't have to worry about moving or scaling or anything with this JPEG document that we're using as our template. Template's a bad word, as our reference material, our source material. All right, well now with our image imported, exploded, made as a component, positioned into place, like we want it so we can reference this line here as our square, and then finally locked, we're ready to start drawing. Now one of the cool things, airplanes are generally symmetrical beasts. whereas one side is going to be the same shape as the other, naturally. Well, we're going to take advantage of an opportunity to draw in, we're going to draw half of the airplane. That way, when we copy and flip that half to the other side, we know we are perfect symmetrical. Plus, it saves the time of trying to draw, two sides and make them look alike. So what we're going to start with, be real simple with this. I'm going to grab my pencil tool, and right up here, let's say about right here, we're going to start a line, and we'll bring it out to about right there. Now we'll hit escape to kill this line that it's trying to draw, and we'll grab our arc tool, and we can plant right on the edge of that first line segment. We can set it up like that. Looks pretty good. Now let's use this again because we still have some curve. Maybe we'll go to about, let's say about right there. And we don't have to drag it all the way out, but we can get it. Yeah, it helps if I'm right there. Let's go to about right there. Looks pretty good. Now we'll go back to our regular tool because I'm not going to get this, there's no fillet on a foamy like this, so we're going to grab the, go there, and then we'll draw another line. It wants to stay on the vertical, but we want to bring it in. Let's go to about right there. And I'm just kind of banging this out to show you what we can get. I'm going to hit escape. I'm going to grab a line segment tool. I'm sorry, not that. I'm going to grab the arc tool. Let's come over here. Now, if you know about foamies and all, this is going to probably yield us something that is, that's too much of a point. So maybe we'll come into about right here, and we'll come out to about right here, and we'll pull that out just a little bit, just kind of round it off. That's too much. The closer you zoom, the better control you may have. I like that. And now we'll stick with our arc tool because there's actually an ever such a slight arc in this fuse. And let's bring it out just a little bit. Feeling pretty good with that. And then we'll grab our pencil tool for our straight line, and we'll join the two pieces. And look at there. We now have, oops, I'm going to take that line and delete it. I can use my eraser tool because when I got sloppy and I didn't take it all the way to the end there like I should have. So we'll hit this end and we'll connect it. Just using my scroll button in and out. Now that looks much better. So now we've got half of the fuse. Now, like I told you, we want to design symmetrically. So what we might want to do here is click once to grab that face, and which is basically the shape. Now, if I click twice, I'll get the whole thing, all the lines and everything. But for right now, once is fine. And if I grab my move tool again, now if I move it, it's just going to move it out of the way. I'm not ready to do that yet. Perhaps instead, we'll make a copy of it. I'll hit my control button once. It's a plus. I'll click on it, drag it over, and now I have an exact copy. Now this is, I'm saving pretty frequently along the way, running my desktop recording software along with SketchUp, and the image and everything else likes to crash it. So now anyway, we have this shape. If I select it all, we're going to flip it. Now we want to flip it along this red axis. So I'll right click, flip along, red direction, and now we have a mirrored copy of this one. We can now grab our move tool, which I can hit M to get it, or you can hit the move tool here. I'm going to grab it in this corner, and I'm going to bring it up here and let them lock right there. I've got a fully symmetrical shape there. Pretty cool, huh? So what I'm going to do now, and I like to do lots of little shortcuts, lots of little tips to help you along the way. We've got a fuselage with the side reinforcements for a profile fuselage. I'm going to grab that all, and I'm going to again copy it and pull it over to the side, and we'll do a save. Now I'm going to delete everything except my center line, because I'm going to use that same center line that's referencing the side pieces for a wing. And we're going to do basically the same thing and draw out one and then flip it along and so forth. And you'll get an idea how this works. So what I can do, a lot of different ways of doing that. I can just do a little marquee select, delete, just taking all these little line segments, do it again here. And the main reason of doing this, it may seem a little cumbersome, but again, I want to keep my referenced center line in place. I notice even though, I could have deleted it here, but I don't want to. We're going to use that later when we're working up the design to assemble the model. We can do the wings now. Maybe we want to do, go ahead and pop a save here. Let's get this first section here. We've got, we're going to say that's about the line there, pretty close. And we got our first section. And now we'll get this endpoint, and we'll come down to this line. We're going to have to use some arcs here to pull this off. Arc tool, little slight radius there. That looks pretty good. I hit my escape key prematurely. Twice. I feel pretty good about that. Click on this one, and now we're going to play with this a little bit. We can get it about right there. This is all rough. We can go back and clean this up later, however we choose. I like that though. Go back to our pencil tool, with this line right on the edge, and we'll draw straight back. And now we have half of a wing. And you can see from my work there, as the face filled in, it looks pretty good. Or at least I think it does. And now we can grab it again, and we'll say move tool with control one time. We'll drag it over out of the way. And then we can flip along the red. And grab our move tool again. We'll get this top part of the center there and do it there. And I'm a little off as far as the entire design. That's just because I didn't have it quite skewed, or quite without skew, but that's okay. Now I can grab all of that information, and we're just going to move this out of the way now. Oh, you see how I'm dragging away those other lines? No worries, that's just because I had a center line going farther than the point of the wing and the tail of the wing. But we can just delete all those. So anyway, that's pretty much how this works. I've been able to, just in a few moments, work up the fuselage sides and the wing. And I could have worked up my ailerons, but generally scale ailerons don't work really well with smaller foamy type aircraft, so I'll work in my own. But that's just a brief rundown on how you can use an imported bitmap or TIFF or JPEG to start working up designs. Now you see my lines here are bold. We talked about it in an earlier exercise that I would want to change my edge style to view, edge style to take profiles off. But I like to have profiles on when I'm tracing an image like that. It just helps me to see it. So we've done our side pieces and we've done our wing, and it was just that easy. So we'll continue on with another exercise. We're going to talk about how to create three-dimensional models. During our last exercise, I showed you how to, with the aid of imported images, work up an airplane concept that you could cut out on your flat printer, and it was a flat plate foamy Bearcat. Well, what you see before you now is another example of that technique being used. I had the need a couple of years ago to put together a little chuck glider that could be used for advertising in a expo type environment. I wanted to have something to hand out to the children and something that would, bring a smile to their face, but also advertise the capability of what I was advertising at the expo. And it just so happened it was the flat printer. Anyway, I worked up this little katana, and again, I used it using the same techniques that I showed you previously. I had an image imported, and I'm going to show you that. First, though, I want to show you another cool tool that you'll want to use. We've talked about basic drawing tools and move tools, and we've talked about some measuring tools and so forth. I've shown you the orbit tool, which allows you to change the perspective angle that you're viewing your model in. I've shown you the pan tool, which allows you to pan around. Now I'm going to show you the zoom extents. That's what this little button here is. And it's going to basically, when I click that, it's going to show me, no matter how far away from my active works and models are, it's going to show me everything within my document. So if I click on this, you'll see, whoa, I'm zoomed way out. And real quick, first, I'm going to show you, this is my bitmap that I imported in from 3View. And from that, using this and the same techniques that I showed you before, from that I was able to work up these two pieces. Nice and simple. And what we're going to do at the end of this exercise, if it all comes out okay, I'm going to show you how to make this, which is our 3D representation of that model. Kind of cool. And it was the whole idea was to have something that could be cut from minimal material, cheap material at that. I'm using the 1/4-inch fanfold foam, but then also to be assembled. You basically slide this piece, the vertical piece, into the horizontal piece, secure it with a couple of dots of hot glue, and hot glue a penny on the front of it, and you're ready to throw it. So that's the airplane that I came up with for advertising's sake. And some considerations. Now, I'm not going to show you how to design. I'm showing you how to use SketchUp here. But some things that I did when I was working this, like I say, I normally like to work in inches, but I like to work in metric as well because I don't like having to deal with, 4 decimal places as much, when I'm working up a design. Now, I have determined in the past that fanfold foam, although it's advertised as 1/4-inch, is really closer to 6 millimeter. So that being known, even though I was all in inches, I was able to work up my slots to be 6 millimeters wide. But what we're going to do here, again, I'm not going to go heavy into the design, but I'm going to show you how to take these models and assemble a 3D representation so that you can make certain that everything fits properly from your 2-dimensional parts. Now you may notice we've got a quadrant here. And over here, this is the quadrant that your flat printer will be cutting in all the time. These represent, your positive movement of X and positive movement of Y. And I have everything over here in this quadrant. As a rule of thumb, I like to work very organized. So any parts that I have that are finished parts that I do not intend to edit anymore, I put them in this quadrant. And I won't make any more changes to these. I may copy from them, but I won't make changes to them. So real quick, we're going to get into this, how you can go about assembling your model once you've got it all designed. So if I were to make a copy of these And again, we know how to make a copy. We can either copy paste, I'm going to do that this time, or we can select the move button, hit the control, and then drag off our new copies. Or I can hit Control C and Control V, and now I have these pieces. So with that, these are not going to be touched. These are my playing around pieces. And there's some things that we can also do. I'm going to go ahead and give these parts some separation so that I don't mistakenly select one or both of them, or elements of both when I'm ready to use my move tool, when I'm ready to put it all together. Something that you can look at here as a rule of thumb, if we've got slots that we're going to line up and we start putting together a 3D model, I really like using my move tool. I like to center everything up to this axis here, just to make sure that everything is nice and straight. I know that these are, but I want to demonstrate it to you. And we can see that this is not skewed. If it were skewed, then I would want to rotate it using our rotate tool to get it onto, one of the 90-degree axes. And this one is like this too. So now that we have these pieces, what we're going to do now, I guess what I'll do, double click, and we're going to go ahead and move this off of this line. We're going to work with these parts individually. Now we're going to use our pull tool. Now I know that the foam that I'm using is about 6 millimeters thick, right? We've already determined that. So what I'm going to do is I'm going to use my orbit tool here to rotate off just a little bit so I can get an idea of what's going on here. Then I'm going to use my pull tool, and that's this guy right here. If I click on that and I click here and I pull up, well, now I've got a three-dimensional part. Now how am I going to know how far is 6 millimeter? Well, I'm going to pull up to whatever size, and we're in inches right now, but I can type in the number 6 mm and hit enter, and now I have a sheet that's 6 millimeters. Pretty cool, huh? The measurement tool works really well. I can do the same thing here. Click, pull up, type in 6 mm. Even though I'm in inches, I've forced millimeters. Hit enter. And now I've got two models, or two pieces of this model pulled out to the right size, to the right thickness. Now we're dealing with three-dimensional elements here, right? It's kind of cool. All right. This would be a good time to show you another function that we have, and that's the ability to paint. Now, if I select here, when we pulled up, we had a blue face. Now it's white. It's no worries. But what I want to do is throw some color on it. And I bring up my paint bucket there, and I can just select a color. Let's go down to, I don't know, maybe a yellow. Ooh, the purple's cool. I guess the yellows are up here. Yellow. And now, any face that I touch is going to turn it to yellow. And that includes these. There's one there. Now, something that you may be wondering is that, I've got some nice arcs here. How did I get those? Well, there's a way to do that using the Weld tool, because what it does is it unifies a bunch of different line segments into one smooth line segment. And we can talk about that later. But anyway, I just go through it. I paint all the sides. If I use my orbit tool to rotate around, and then I can click here again, and now I'm back to my paint bucket. Orbit by hitting the O, back to the paint bucket, which I think is B. And we'll click here and orbit to the bottom side. We don't want to forget that side because how we're going to represent this. And Now we're ready to work on this one. So I can click there. We're just basically giving it a nice little yellow paint job. I'll basically try to get all the pieces that I can see easy enough, and then rotate around and try to get what I've missed. I don't really have to get these pieces in here because they won't be seen. What I'm trying to basically show you here, though, is just how easily this is all done. Yeah, that's good enough. I think I got it all sides. Okay, close that window, go back to my top-down view. And incidentally, if you want to real quickly get back to your direct select tool, then you can naturally hit that, or you can hit your space bar. And now I'm back to direct select. So O for orbit, we can see we've got some parts here that are ready to go. Now there's some work that's going to have to be done in order to put this together. First thing we need to do is take these parts and we're going to make them into components. So now that we have more than 2 dimensions, now that we have 3, I can click it once, or I can do a double click and I'll get that all the elements of that one face, but I want to do it 3 times now. 1, 2, 3. And now I've got everything in this particular piece. I can right click, I can make it a component. I can leave it as component number 5, or I can simply just call it fuse. Now we're going to do the same thing here. Click 3 times, right click, make component. We're going to call this one wing. Create. Now by doing this, these parts, you saw in an earlier exercise when I did the Bearcat wing, when I pulled the wing away, even though I had other lines that were touching it, that down my center line for my fuse, and I had just the wing selected, well, because it was the wing was still in contact with those other outside lines, it did not pull the wing away from those, it stretched those. By making components here, now if we are assembling this model and we don't get it right the first time, when we go to pull it away, because it's a component, it won't interact with the other parts, line segments. Very important. Now what we're going to do is we're going to do a rotate. This piece needs to be rotated -90 degrees from the perspective we're in. So we can select it. We can go to our rotate tool, which is also our Q. And real quick, I'm going to change my perspective just a little stronger. This will be probably one of the most frustrating things that you'll find about SketchUp. We want to rotate it right here. But if I tried to do it right here, it would be almost impossible to find the right angle, if you see what I'm doing there. So if we do it here, where we know that this is already 90 degrees to the green line that I showed you earlier, then we know that this is a great place to rotate. So we want our green, we'll select it, we'll pull out a line, we'll go this way with it, and it'll lock to 90 degrees. We'll select again, and now we've got that piece. Like I say, this may prove many times to be very frustrating, because dealing in perspective 3-dimensional views, it can be really hard sometimes to make SketchUp do what you want it to do. So I warn you that up front. But with a little bit of practice, you'll get it. You'll learn the little tricks like that one I showed you. Now, the next thing is trying to put this piece onto this piece. Now you may ask yourself, or you may say to yourself, that looks pretty easy, no big deal. Well, it's not. So what I want to try to do is I want to try to select 2 points that I know should come into contact once I've finished, placing this piece with this one. Well, I know, because these are slots here and here, that I know that, say, this corner should end right here on this corner. And if you attack it like that, you're going to find that it's going to work, much better. So if I take my Move tool, or M on the keyboard, and I select that, right? Click it once. I'm going to zoom back out. Now I should be able to bring it over here. And see, it's going to be a little funny on us, but usually once you get the angle right, it'll be okay. I might try to go here. We'll stop there and get a new angle. Rotate it around a little bit. Go back to my Move tool. We got closer. There's another way of doing this that helps considerably, is we can go into what's called, I showed you our views here, we can go into our wireframe mode. Now you got to watch out, because if you have a lot of lines going on, sometimes it's kind of hard to make things happen right. It's hard it confuses the noggin. And I'm already confused. My highlight is my part moving, so I should be able to select this and maybe now lock it in. Look at there. And it locked right in place. Now if I go back to I click off of that wireframe view, go ahead and deselect everything, get my orbit tool and move around here, and I can see that I've assembled this simple model just like I wanted it to. So that will give you a little bit of an understanding on how to assemble 3D components, how to pull them out to the size that you need them to be, in this case the thickness of your material, using 6mm thick foam, and put those pieces together. So that is, again, that is assembling a 3D model from a 2D starting point. And we'll continue on in a bit. Something that I want to be sure and forewarn you about when you're doing your 3D assembly, in the case of this example that we've used, we've got, there are only 2 pieces, so it's real easy to do, but let's say you're working with multiple pieces. Let's say you're working with, a wing. Each wing has the wing has 2 ailerons. The elevator, the elevators are hooked to the horizontal stab, a rudder to a vertical stab, things like that. The way that I would go about it is I would assemble all the pieces of the wing. In other words, I would make the wing a component, make an aileron a component, make the other aileron a component, slide those in place, and then now make all 3 of those components a component again. In other words, you can say, wing, left aileron, right aileron, those are 3 components, and then once they're all snapped together, then you could make all 3 of those components a final component. And then that way, when you're moving maybe a wing with 2 ailerons into position, you don't accidentally forget to select one, or you select 2 but not the 3rd, and so forth. And just to show you that, I've got this where I've got the horizontal plane component, the wing. I've got this, that's the fuselage. Well, if I marquee select all of that, then I can go to make this a component, and then I can call this maybe something like final. And now anything that I do to this, I don't have to worry about accidentally not selecting all of the components that I want to move as one unit. I can actually, just click it one time. It's a full thing. And you can keep stacking components to components to components as you go. Now, if I wanted to, I'm going to go ahead and make a save on this. But if I wanted to maybe take this back apart and say, I don't like that, I want to make some changes to it, I want to save, maybe the wing is fine, but I'm going to make changes to my original part of my fuselage over here, and then pull it out and reassemble it and all that. Well, you may choose to explode. You can select everything here and then right click and say explode. Now what that's going to do is that's going to remove the last component made. If I had everything selected and I said explode again, well, then what I would end up with would be just a mess of line segments, which may be what I want to do. But I wanted to be sure and show you that because, as a, pro tip, if you When you have something that you think is finished, make a component. If you add other pieces to it, make a component. I make separate components out of every single piece. Then I start assembling them and then make, group components, we'll say. And then finally, when the model's completely done, then I have a final component that I make. So just to share that with you, something that will aid you when you're going through the rigors of assembling 3D models. It's not that it's real hard to do, it's just that I found it to be the most frustrating to learn. And sometimes, even with all the experience that I have making 3D models from two-dimensional parts, sometimes I still get hung up. So I wanted to be sure and share that with you. I wanted to take a moment to try to explain to you some tips and a little bit about some of the plugins that we loaded. And this is a good aircraft to show you in some of the tips that I've used here. This is the Lanzo Bomber, originally by Chet Lanzo. I guess back in I want to say like in the 20s or the 30s. And I worked this up for a friend of mine up in Indiana because he didn't have a really good command yet of SketchUp, but he wanted to get this thing going. And I wanted to talk about some of the elements of this particular airplane. This is an old-timer design, and it's actually a pretty neat little airplane. But I wanted to take a moment to show you some of the cool things about this airplane. Get my orbit tool so we can look around it. First off, this is a fine example of how I've used multiple components. For instance, I worked together this center wing, this piece here. This is a KF strip on the top, but I took the center wing and made that a component. And then I made the KF step on the top as another component, and then I brought it up and stacked it right in position, the top step to the bottom portion of the wing, and I made that all one component. And then I did those same things here with the wingtips. I made this piece a component. I should get my pointer. I made this piece a component, this piece a component. I lined them up on top of one another, and then I made them together a two-piece component. And then once I brought it up into position and put it onto the wing with the proper amount of polyhedral, then I made this and this a component. And then I went to work on this piece, doing the same thing, one component, a second component, made the two together a component, brought them at the right angle, and joined them to this big component. Anyway, that's just an example how all the components work together to allow you to more easily assemble the model. Now another thing you can see, I'm just playing around here, but if you look at the elevator halves, if you look at the elevator, well, the elevator and the rudder, we've got some up elevator and some right rudder going on. And by my assembling like I like to do, I made of the horizontal stab, this was a component, this was a component. I joined the two together to make one component, and then I made the elevator half a component, and then pulled it into position, rotated it up along with its mate over here on this side, and then made that whole horizontal stab a component. So I just wanted to show you how well that kind of situation works. Now, because this is fully 3D, it's been all assembled, it really shows the person that I might pass this on to how this model assembles, how it goes together. It's it's almost as good as an exploded diagram. I could have made an exploded diagram if I wanted, but here we've got a fuselage that juts up to the wing mount off of a pylon, and then I've got more foam on each side showing how we can make that all a stiffened member. I've got the side parts here, the horizontal bracing, which takes us into some more things here, some more interesting things. I wanted to talk excuse me, I wanted to talk a little bit about about tabs and slots. All of these parts here you see are the parts that we would cut out of 3 sheets of foam to make this airplane kit. And through careful consideration and working it out, I was able to work up tabs and slots, and everything, goes together real nice. It's almost idiot proof. And when you put together a model that, being a flat printer owner, you may want to take your next creation and take it to the market and make money with it. And when I build my models, I'm always, adamant about making them idiot proof, because just because I understand how it all goes together, the next person down the line, whether I've shared these plans with them or I've sold them a kit, well, I want them to be able to understand as well how to put it together. So tabs and slots are something that work real well. If you look at this main piece of the fuselage, you can see how I've got 3 holes there, 3 slots, and I've got these side braces that also have tabs. And I want to show you just briefly how this all goes to be. Now these are 2-dimensional elements, so I can just double click to get them all. And I'm going to Control C and Control V to pull that piece out. Do the same thing with this one. This is a slot method, tab and slot method that I like to use. Now I had to lay these pieces down. I'll just kind of show you, but when I knew the center line of where they were going to be, I was able to actually take these pieces and pull them into place onto the center line. And again, our little marks there help us to understand where the centers are. But I was able to work it all up and decide where to put my actual tabs and slots. And you can see here that, and I don't have these made as components, so I can't move my mouse around. But the bottom piece that's shaded is showing how the right side stiffener would go in and then utilize half of that slot width for fitting in, and it leaves the other half open for the other side. And it allows us to have the fewest number of slots and the greatest number of tabs. Everything just fits together real well. And since these are burn pieces, I'll show you how you can do that right here. But what I basically did to pull this off is I just worked up, I figured, okay, my material, 6 millimeters thick, so the spacing in here, from here to here, that's 6 millimeters. And then I made the side braces like I wanted. And then I determined, well, I think I would like to have 3 of these, one in the middle, one near the nose, but not all the way to the nose because we want strength up there. And then one back here. And then since this is such thin material anyway, it's kind of more for, cosmetic than it is anything else. So I didn't bother trying to tab and slot that far back. Plus, I would have had this cutout for my horizontal stab that it would have interfered with, and it just would have made it would have been trouble. So I set it up like this. And knowing, I'll use my eraser tool, but knowing that I had 6 millimeters apart for the 2 side pieces, then basically I went in, and drew this little zigzag shape so that I would have tabs on each piece that went into the same slot. This makes for very strong pieces, and parts fit, and it just works really, really well. And these are things that you might consider doing. Just as easily, I could have taken my pen tool. I would have automatically found the center mark, which you can see it's highlighted there at the midpoint. That means 3 millimeters in, and I could have drawn a line like that. But that didn't give it quite as much meat to go into, and these types of tabs work much better. They're much stronger, and they'll last a lot longer and hold up to more abuse. These, they typically will bust the glue joint apart through hard flying. Not that we ever crash airplanes, right? But nonetheless. So I wanted to show you that. Now I also wanted to make a note about once you have, let's say, pretend like I didn't do this. I could actually Control Z back and put those marks back. But once I have these pieces drawn up, there are, let's say I wanted to pull them apart to separate them so that I can cut them on my CNC machine. Well, I can't just select one and move it, because you see what it does to the other part? That's no good. So what I do, and it's just real easy, what I do is once I have that part, I'll just grab just the face, and then I will simply, I can select my move tool and hold my click my control button and move it like that, and then do the same thing here. Select my move, which is M, or again this guy here, and hit my control button once and pull it apart. Now I have two accurate pieces, and then I could just delete these pieces right here. And there we go. And that's what I have done over here. Now something that you know can rear its ugly head from time to time, and I've incorporated this into my design process when I'm going to cut out something that I've designed in SketchUp on a CNC machine, something that I want to share. If we look real close, these are nice arcs right here, and this airplane has arcs all over it. But sometimes, and they don't look that bad here because of what I've done to them, and I'm going to show you that. But sometimes if you have a line segment like that one, you'll see that that's, you know, it's arcs going in different directions, but when I click on it, the whole thing lights up. That's one entity. That is an example of using the Weld plugin. If I wanted to come over here like to this one, that's a line segment, that's a line segment, and so forth. Well, if I will take and select the whole thing, and I can deselect by holding my shift down, take the face off, and I can go up here to this plugin and hit Weld. And it says, do I want to find faces for this curve? Well, I always answer yes, but the curve already has a face. But in doing that, now when I select the line, you'll see that the whole thing lights up. That means that is all one entity. Now, the reason why I do this, oftentimes when you're dealing with arcs, the way SketchUp deals with them most of the time is it deals with them as faceted arcs. Lots and lots of line segments, sometimes tiny, tiny ones. When you send this gCode out to your flat printer, it's when it's generated and then sent out to your flat printer, sometimes all those line segments will be treated in such a way that the machine will just hop around and cut random. It may cut one here and then come over here and then here and then here and so forth. Using the Weld tool, anytime you have arcs like that, to unify all the line segments as one will mean that when you make the machine code to go to your CNC machine, it will cut that piece out in one, you know, continuous motion. So that's something that I thought was worth bringing up, because if you don't get in the habit of doing that and you're making your files for CNC machines, you know, you can take a file that might cut out in 5 minutes and then make it take 2.5 hours. And I know this from experience. So I wanted to share that information with you. That is a very useful plugin. Now I had planned to show you another plugin, and I can make I'll make a new file here. But let's say we had an element. We'll just make a circle there, and we'll say view, edge style, profiles. Get our nice smaller line segments back. But let's say for some reason we had opened up somebody else's file, or we had been working on a file. I can't say you'd be working on, this happens a lot when you imported DXFs in the older versions. Since we can't really do DXFs anymore, then it's kind of a moot point, but I wanted to show you this tool anyway. If I were to select this element and I were to move it and move it off of our two-dimensional plane, you can, I don't know if you'll be able to see, but the little dotted lines that are showing where I've moved from, they're blue, which means that I'm moving them up and off of the XYZ plane here. Well, there's a plugin here that we use, and I'll get it back here. You can see how that's hovering now off of our work surface. It's up in the air. And that's not, that big of a deal, but if you're working in two-dimensional and you're getting ready to lay out, cut files for your flat printer and so forth, it's imperative that this be on the Z-plane. Everything needs to be flat to the Z-plane, to the table. And with that selected, I can come over here to, I can actually right-click it when it's selected, come down to Flat Edge, and I can say Flatten Selected Edges. When I do that, that brings it all down to the Z-plane. And that may be a tool that you find useful. If you're using an older version of SketchUp, like 7.0, I personally still have, you may have seen earlier, I still keep SketchUp 7 in my computer on all of my machines because that version allows me to import DXF. And sometimes I find a DXF or a DWG file that I really like, or sometimes maybe I want to work up a DXF or DWG file that I've generated myself from Illustrator. Well, when you import those types of files in those older versions of SketchUp, sometimes you're going to find it just impossible to make a face, to get a face to show up, even though you see all of the line segments are perfect and everything is joined and intersecting. And that may be very well that you don't have everything flat to the Z-plane. And by taking a plug-in like this and selecting it, right-click, flattening it, then you'll be able to get a face after that. So I wanted to be sure and share that information with you. Next up, we're going to talk about the PhlatScript. So you'll want to watch this one closely. At this point, you should have a pretty fair understanding of how to draw in SketchUp, how to create two-dimensional parts in SketchUp, how to pull out those parts into three-dimensional entities, and then assemble them to make certain that they fit all correctly and all. Well, now we get to the fun part with Google's SketchUp. Using the Flatboy's PhlatScript, which is a free plugin, we can generate gCode. Now, what is gCode? gCode is a set of instructions, basically, to tell a CNC machine what work it is going to do. And that's pretty much what it is. Now, because we generate the gCode in SketchUp using the Flatboy's PhlatScript, I call that FlatCode. That was a term that was coined back with the Flatboys early on, and I have just stayed with that term. Yes, it's technically gCode, but I call it FlatCode. Now, the example that I have before you now is something that I've worked up. It's my rendering, my rendition of Laser Toys Mini Arrow. It's a spry little delta that flies really nice. You can build it out of, a host of materials. I use fan fold foam for mine. And it's just real simple. I banged it out in no time at all, just given the dimensions. And fortunately, the Laser Toys people allowed me to kit this and to share this design. So you can find my files on this over at the Flat Forum. But anyway, I've taken my two-dimensional parts. I've made three-dimensional parts into them. I have fully assembled the model to make certain that it all fits and works as I had planned. And now we're to the point where we're ready to generate machine code. Now with that, I'm going to show you some, I'm going to give you a little walk around through the PhlatScript and show you how it works. And we will generate gCode that we can use with this design, use our flat printer to cut it out, and have a successfully flying airplane kit. All right, with every new model that we've worked up, before we can start laying out parts and cutting our parts out and so forth, we have to know a couple of things. We have to know what foam we're using. Of course, at this point, by the time we have developed our three-dimensional model, we know what foam we're using. Are we using 6mm EPP? Are we using 6mm Depron? Are we using roughly 6 millimeter, say 1/4 inch fan fold foam? You want to already know that so that you can get your tabs and slots and everything correct at that point. But now it's time to look at a few other things. What size foam do we intend to use? What bit are we going to use? All of these things are going to have bearing on how we set up our PhlatScript. So at this point, we are ready to define the criteria for this design. Now I'm going to back out here. That's my 3D model. Here are my parts for this design. Now, what we see here is we have some slots and we have tabs. We have a cutaway for our prop. We have all of these different materials. Now, in the way that I've laid this out, the way these parts are all laid out, I've already tried to bunch them all up and get them to where they'll take, I guess, a minimal amount of foam, so I have more yield, less waste. I know for this particular design, I know that I'm going to be using fan fold foam. Now, fan fold foam, I can get sheets of that by the time I cut them out of the bundle. They're approximately 2 foot by 4 foot. So we want to set up our criteria now. We're going to click on this first icon in our PhlatScript toolbar. Now this is going to give us our parameters. And it's very important to have these parameters set where you like them, because this has a bearing on the machine instruction. We'll first start off here with spindle speed. Now, most of the guys that are using the PhlatScript just don't fool with this. Spindle speed, 8,000, we just leave that alone as an arbitrary number. Now, as we advance with higher level CNC machines and so forth, we will have, we will certainly want to maybe experiment with that spindle speed. But right now, we just leave it alone at its default value of 8,000 RPM. Now, feed rate and plunge rate. These are relative to how fast the bit travels through the foam. In other words, when we first puncture into the foam, when the Z gantry first allows the bit to move into the foam, at what rate is that going to be moving? Now, this is inches per minute. Now, for most of your, well, in this case, I know fan fold foam, I can plunge into that material at 100 inches per minute without any problem. Now, with feed rate, that is something that you may want to consider. It depends on your machine's capabilities. I'm using right now an MK2 flat printer, and I have demonstrated with that machine, with the Flatboy's 1/8 inch bit, the stock bit, and that machine in fan fold, I can very easily cut 200 inches per minute. So I'm going to change that to 200 inches per minute because I want to maximize processing. You know, I want to get this thing to process as fast as I can. And I won't give you too much on CNC theory other than the fact that you need to understand your machine's capabilities. Your machine, if you're using an original flat printer, what some of us have called an MK1, well, most of those machines are not capable of 200 inches per minute. And at any rate, you'd want to set up the rate at what you know your machine can do. In this case, again, I'm setting up 200. Now, this is where we put in our material thickness. And I'm going to leave this at 1/4 inch. That's a default value because that's pretty close to what fan fold foam is. If I wanted to change my units of measure and maybe deal with 6 millimeter or even 3 millimeter, I could do a conversion, put that in, or I could just change my units of measure like we did in our template. Go to the preferences and go down to the units, and I could change it to millimeters if I wanted to, and it would change the document wholesale to millimeters, and I wouldn't see 0.25 here, and you could put in whatever thickness of material that you have. I'm just going to leave mine at 1/4 inch. I know that that works really well with fan fold foam. Now, our in-outside cut, overcut percentage. What this is telling us, and this is a default value, 140 stands for 140%. which means if I've got a 1/4 inch material, I'm going to, once I set my bit up, I'm going to enter into that material a 1/4 inch plus 40% of a 1/4 inch, which whatever that is, less than 1/8 of an inch. And that just allows us to make certain, because of the waviness of the fanfold foam in this case, that allows us to make certain, that we're completely entering into the foam at all times. I'm just going to leave that alone. My bit diameter, this is very important. If you're using, in this case, I'm using a 1/8 inch bit. This measurement here needs to be as close to accurate as you can get it. If you're using an 1/8 inch bit, use an 1/8 inch value here. If you're using a 1/16 inch bit, again, use a 1/16 value here. The reason is because this portion of the formula calculates how far to offset the cut path when we're ready to generate our cut files. We're not going to be running the bit right along our vectored element part, because if we did, then we would end up with a part that would be slightly undersized. Naturally, it would be a 1/16 inch undersize. So we want to take an offset path on here, and the PhlatScript is going to do that for us if we have the right bit diameter. I'm using a 1/8 inch bit, so I'm going to leave this here. Now, tabbing. This is a good number here. I've used all different types of tabs, but I wanted to show you that this tab value is the default value, and this is going to mean that our tabs are going to be about a 1/4 inch wide. Now, you may ask yourself, what are you talking about, Crash? What is a tab? Well, when we're cutting out all of our pieces, if we allowed our blade to enter into a piece and then just cut it all out, well, then once we completed that cut, that part would just simply fall out of the sheet. Most likely what would happen is it would sit there and vibrate back and forth until such a time that it miscut. The blade would dig into it or whatever. If the parts fall out of the sheet after they're cut, then what we're going to end up with is a jam of our flat printer or our CNC machine, whatever kind we're using. And well, that's no good. It'll jam up the machine, it'll stop, you'll ruin a piece of foam, and you'll never get an airplane out. So what we do is we put in little tabs, and tabs are, in the printing industry, we call them nicks in the printing and packaging industry, because they're basically little bridges, little pieces of foam that are not cut that hold that part into place so that it can't fall out of the rest of the sheet. And of course, when we're finished cutting out all of our pieces, we can go in and just pop the pieces out, or perhaps we'll use an X-Acto and just trim, real quickly those little pieces, little 1/4 inch pieces of foam away. So that's basically what a tab is and how it relates here. I find that on fanfold foam, on Depron, on various hosts of foam materials, 1/4 inch is just fine. So rarely will I touch that. Now this is our tab depth factor here. What does that mean? Well, this is basically how far we're going to push the bit into the foam on a tab. We can set this at 0, and that's going to mean that if we're cutting parts out of a 1/4 inch piece of fanfold, then the tab is going to be a 1/4 inch wide, and then the height of that tab is going to be the full thickness of the foam. Well, we find that with flat printers, that means that you're most certainly going to have to take your X-Acto blade or some razor or something to cut all of the pieces out. Now, if you change that value to say 50%, to where basically you've got a 1/4 inch wide tab, but now it's only 1/8 of an inch thick with foam in those tab areas, well, then you have a greater opportunity to just punch the part out when you're finished. Or if you have to cut it out, it's just a quick, slip of or a slit with the razor, and it just cuts it away. 50% is really good, I know, for the material that I'm using. Now, if you were cutting wood, maybe you've got a piece of MDF that you're wanting to cut with your flat printer, and you might decide that, wow, 50% tab depth, now we're talking about MDF that's a 1/4 inch wide by 1/8 inch deep, and I'm going to basically have to take a chisel to knock all of these tabs loose to free my part from the sheet of material it's in. Well, then you might want to go to a deeper tab depth. Maybe you want to take it to 70, 75%, 80%. You don't want to take it too deep, because then the part will, just through the vibration, as the MDF in this case would be going back and forth, it might want to vibrate and break itself loose. So this is, again, has more to do with your machine's demonstrated capacity. You may decide, depending on your feed rates and so forth, you may decide that, maybe 50 is not enough. You've got tabs breaking loose. Maybe you want to change that to a different, maybe a lighter depth, maybe a 25% or whatever. But for what I'm cutting out, 50% is going to be just fine. Then that brings us to our safe length and our safe width. Now, I know, I've already told you, I'm going to use approximately 24-inch by 48-inch piece of foam. In actuality, by the time I trim my fan fold out of my bundle, it's going to be more like 23, maybe 22.5 inches. Well, what I'm doing is I'm setting up, these two measurements here are going to set up my bounding box. They're going to tell me basically the parts have to fit within this. If I have any parts outside of this boundary, then the machine's not going to process the code in those areas. So I know for a fact that my width is going to be about 22 inches from the sheet when I load that sheet into my flat printer, nice and straight and true. But the length, now I told you that I had a 48-inch long sheet of material, but I'm putting in 42. Again, this is dependent upon your machine's demonstrated capacity. I know that with my flat printer original machine, if I put in a 48-inch length of material, I had to lose approximately 6 inches of material. I believe it was 2 inches on the front of the sheet, 4 inches on the back of the sheet, and the reason is because I had to have that foam stay in between the pressure roller and the drive rollers, so that it would get traction. If I tried to use that whole sheet of material, well, then the foam would spit out and then lose traction on the rollers, and my job would be done. It would be finished. On the MK2, I think I've reduced that down to 4 inches, and I don't know what it is on the MK3 right now, but I just leave everything standard for the MK1, the original flat printer, at 42 inches when I'm doing fan fold foam. So we'll just leave those alone. Those are the default values. Now, this next checkbox, overhead gantry. This takes into consideration something that a lot of people don't understand. You have, in addition to your feed rate, you have an inside cut and an outside cut. And those are relative to the direction of travel that the bit follows. Keep in mind that your bit is going to be spinning at one direction all the time. It's either clockwise or counterclockwise. I forget what it is, but with the MK2 and the original flat printers, that Dremel that was used, or RotoZip, or whatever the spindle was that you may have on your machine there, it would be spinning it was spinning the reverse direction that most overhead gantry CNCs would spin. And the PhlatScript was set up so that if you're cutting, let's say, around the outside of a part, like around the outside of an elevon here, then the bit would travel in one direction. And the goal was that one side, your finished part, would have a nice, clean, sharp cut, while the other waste area would be the rougher side of the cut. And the direction of travel was complementive of that, so that your finished parts look nice and sharp and clean. Then when you do an inside cut, like when we notch out the inside of this prop slot, well, then the bit would have to travel in the opposite direction, so that this material inside here was the scrap and had the fuzzy rough side, and then again the finished part would have a smooth side. Well, when we try to use the PhlatScript with overhead gantry machines, like the new PhlatPrinter 3 that's going to be released very soon, or maybe I want to use this script like I do often on my overhead gantry commercial type machine, well, then I needed to be able to inverse those particular directions of cut. So this gives us that opportunity. The overhead gantry, if I have an overhead gantry machine, I would check that, and that's going to set correct, an outside cut equals this cut direction, and an inside cut equals an opposite of that cut direction. So if you're using, I guess in a nutshell, if you're using a PhlatPrinter Original or a PhlatPrinter MK2, you want to have this box unchecked. If you're using a PhlatPrinter 3, or perhaps like I have an overhead gantry machine, then I would check this box. Now I run my MK2 for this project here, so I'm going to leave that box unchecked because that's an underhead gantry or an underslung gantry machine. Now let's say that we were dealing with a harder substrate. Maybe we were wanting to use our PhlatPrinter to cut maybe some light ply for firewalls or heavier parts, thicker parts. That's where this multi-pass comes in. It's going to allow us, let's say you have a PhlatPrinter MK2 that's running at easily 200 inches per minute. And then you say, well, I'm going to burn a bit up or break a bit if I try to drive it through maybe 1/4 inch MDF at that speed. Well, then first thing you'd want to do is adjust your feed rate down to something a little more manageable. I happen to use, when using the maybe an 1/8 inch bit or a 1/16 inch bit, I'm running about 40 inches per minute. So I would change that here. But then also, how deep do I make each pass? Do I plunge completely through the material and cut it all in one pass? No, not with harder materials like that. Generally, I try to make cuts of about, about a 1/16 of an inch. So if this were MDF that I were cutting this plane out of, which is kind of silly, but if it were, then I might want to say, well, I know my machine can use a 1/8 inch bit and can easily do 1/16 inch passes. I'm going to generate a multi-pass so that I can cut this in small increments where maybe I push the bit in and the first cut cuts all of the outlines at 1/16 of a depth. And then after it finishes that, then it plunges an additional 1/16 inch and makes those passes again, and then does it again and again until it's finished. That's what multi-pass does. It allows us to cut parts in smaller chunks so that we can run faster machine speeds, but then not bury the bit, not burn the bit, not break the bit. And in actuality, where you could probably plunge the bit fully, depending on what bit you're using, fully into the substrate, MDF, well, you would have to go so slow of a feed rate so that you don't burn the bit up or catch fire or friction fire to the wood. Well, then, it would take you hours to cut out your parts. Whereas if you keep your machine speed up, in this case, like if it were MDF, I would do 40 inches per minute and take maybe 1/16 inch passes. Well, I could finish this whole file in, 20 or 30 minutes. So that's what multi-pass, that's just a little bit about multi-pass. Of course, we're using fan-fold foam, so I will leave that off. Again, multi-pass depth, that is dependent upon your machine's demonstrated capacity. How fast you can process, what depth cuts you want to use. That's all dependent upon the bit you're using and your machine's specific characteristics. So again, foam, you don't really have much need to do a multi-pass on a foam unless you were cutting into maybe a 2-inch block of foam and your bit just didn't have that much, didn't have 2 inches worth of flutes. We're talking about things outside of the norm, of course. And then comment remark. You can put in comments here to say, maybe this is for fan-fold foam, I might say, at 200 inches per minute, and anything else that I want to put in there. This is going to put a little header in your file, in your PhlatCode file, that will be visible when you view the PhlatCode, either in Mach 3, which is our post processor that actually pulls the machine code and says this is the signals that I need to send to to my CNC machine. That's where you might want to use these. I just generally just leave it blank. Well, anyway, we've got everything set up like I like for this airplane on fan-fold foam, so I'm going to say OK. And the first thing you're going to see here is that we have a bounding box. We have 42 inches long by 22 inches wide, and I know if I can put all of these parts into this area here, not have anything hanging out, well then I know I'm going to be able to process this file without dropping off any codes. I just need to make sure that however I place all of my parts into the sheet, that they all fit within that sheet. Okay, you can see I've got my parts on my upper left quadrant like I've shown you before. I don't intend to make any changes to these parts, and because of that they're going to stay here. I'm not going to drag them straight over here. This is just my working technique because I don't want to make any changes. I know these assemble into the 3D model, so I have no desire whatsoever to make any changes to them. So instead I'm going to copy them. And I'm going to hit my Control button one time. So I grab the Move tool, hit Control, and click on it once, and then I drag it into position. And I'm just going to try to center it into the sheet a bit. That looks pretty good right there. Now if I look closely, I'm not too close to the edge here, not too close here or here. So it looks like I've got pretty good placement. Now just real quick, I want to give you a little pro tip on laying your parts out to fit your sheet size. Naturally, if I've got this much material, I don't have a need to bunch up my parts quite so tight. I do this because, well, when I'm all finished, I will probably take all of these elements and make a copy of them and bring them over here, and then I can cut out 2 airplanes at once. That way I maximize my sheet of material. Just try to, if it's a combat type, pylon type race plane, instead of cutting out 1, why not cut out 2 and give 1 to a friend or have a backup or whatever. But when you're moving parts around, I want to share a couple of things with you. First thing to remember, we have a 1/8 inch bit that it's going to be centered 1/16 off. That's, the radius of the bit, so that as it cuts out this part, we can expect that there's going to be a 1/8 inch path away from this part when it gets finished. And then this one is also going to have that same 1/8 inch path that the bit is cutting away. So we don't want to have it so if I were to move this part, just to demonstrate, if we were too close, then maybe by the time that bit cuts all around, well, it's going to cut into this part and it's going to yield a poorly cut part. It's not going to be accurate. It's not going to be correct. I'm going to hit Control Z to move that back. So when you're placing your parts, you're nesting them and trying to get them so that you can maximize the use of your foam. Don't get too close. Always try to keep in mind, okay, well, if I've got a 1/8 inch bit, I should probably make sure that no part is closer than a 1/4 inch. Probably I'd give it about 3/8 of an inch, so that I've got material not touching and the bit's not cutting out of what would be a good part of another part. Enough said. Now also I have, these parts were not all turned and rotated and so forth like you see here. I did that to maximize the foam use. And one thing I wanted to share with you, as you're working with parts, I've got it selected. If I hit my rotate tool, then I can click on this part and I can, work it around. Well, if I were to let that part touch and then I release it, well, now this part has become part of this. These two parts have become one. And it's going to be kind of a pain to, when I maybe miscalculated how I wanted to rotate the part into place, I can see that I've got some funny stuff going on here. If I try to simply rotate that part back while it's touching this one, we're going to mess up 2 parts, maybe even this one if they're making contact. So Control Z to get out of that. Easy to save yourself. But through experimentation and working around, plus we've also got our final finished parts here. If we screw something up, we can just delete all this mess here and start over. So something certainly to consider. Now with these parts all nested like I like them to maximize the use of my foam, I am pretty much ready now to start applying codes. Now I showed you our first button in the PhlatScript, which is setting up our parameters for our job. The next button is going to be our outside cut. It's going to cut the outside path of all these parts, and it's going to go in the right direction because of what we set up in our parameters window. So if I select this button and I bring it over here, you'll see I've got a little O by my arrow, and that means outside cut. And if I hover my arrow over this part, you can see that I've got a red line, and that's basically telling me if I click now, that's going to be the path of my bit. And I like that, so I'm going to go ahead and click it. Now you'll see we've got this color here showing us, that we've got a path now established for our outside cut. And for all of my outside cuts, I'm just going to do the same thing. So click, click, and so forth. Very easy to do. PhlatScript just makes all of this so easy. Well, now I've got to address my inside cuts. If I use this bit or this tool here, then I'm going to be cutting into what I expect to be good material. I don't want to do that. So we're going to go over here and get our inside cut tool. I'll click on that. And then now we've got an understanding of a path that's going to be applied to the inside of the part. So if I click now, okay, I've lost the face. That's cool. I haven't actually lost it. It's just not showing up. But now we can see we've got this blue line to tell us that we've got an inside cut going on. So I'll do that to all of the parts, or all the places on the parts that I expect to be inside. Now you'll see on this one, if I don't hover right, well, it's wanting to apply the inside cut here. I don't want that. So I'm going to get right in this part. And there we go. So that is fairly simple. Or at least I think it is. I have played with creating codes off of other software like CamBam and so forth, and they can be considerably more complex. Looks like we got a little thing going on here. Sometimes you'll find SketchUp will act a little funny. Most often it doesn't. If I hit Control-Z and I get rid of that, let's see what we've got here. You have to be prepared for this stuff. I'm going to take my pen tool or my direct select tool and click here. Okay, I see that these look good. I'm going to just kind of reinforce what's going on here. Okay, let's get our inside tool again. And let's see what that does. It looks like it's not working. I've never had a problem with this file before. Well, I'll fix that in a moment. That should not have happened. And from here, well, the next step we have to do is set some tabs. Now, with our tabs, without our tabs, with all of our cut paths, if we generated code right now to go into our CNC machine, well, we'd have a problem. We'd have parts falling out after they were cut, and that would jam the machine up, and all would be awful. It would be a pain. So what we need to do is establish tabs now. Okay, as you can see here, I was able to fix these little slot issues. It was just because I've been saving back and forth in different versions of SketchUp to try to make it all work for us. But it's fixed now. Well, what we've got now is we've got all of our cut paths established. Now, the problem we have, though, is that with these cut paths, we don't have any tabs, any little bridges of material to hold the foam into place. So the first part that gets cut out is going to fall out of the sheet, or want to fall out of the sheet, and jam up your machine, which is not good. So we got to add tabs. Now we're going to come over here to our tab tool. It looks kind of like this, and if I click on that, Well, we're going to see a little T beside our arrow, and that basically tells us that we're ready to make tabs. Now, there are two different types of tabbing that you can use with the PhlatScript. The T is the default, and basically to show you a little bit about that, first off, we can a T tab is going to look like this. I'll talk about that in a moment. If we hit our V button one time, well, that changes to a V tab configuration. Hit the V again and it takes us back to T. Now let's talk about those tabs. I made this little diagram here, crude as it is. If we could imagine our bit traveling through the foam, and maybe it's cutting. Remember, we're setting up for an original flat printer or a PhlatPrinter MK2 where the gantry is below the foam. Well, the bit is going to be cutting. This is our 140% depth cut of 1/4 inch material. Well, when it comes to a place where it's going to make a tab, that bit is going to stop, retract, however much, in this case 50% of the width of material, and then it's going to start again to complete cutting a portion of the material, and then it's going to stop, and it's going to re-enter the foam at the full 140%, and then it's going to continue on its merry way to complete the part. That's what the bit is doing in a standard tab configuration. Now, if we do V-tabs, we're going to make another little diagram here. If we do a V-tab, it's going to be like this, where the bit is traveling through, and then instead of stopping for the tab, it's going to keep motion, but the Z axis is going to be withdrawing the bit from the foam at the same time that X and Y are still moving. And it'll continue on its way and plunge back into the material, and then continue down. So what we end up with, and I know that is very crude, but what we end up with is this case. This makes a nice strong tab, and it's really good with our 50% tab depth like we set. But the machine has to stop for every tab that it does. It'll stop, the X and Y axis will stop to move the bit with Z, and then they'll start again, and then stop, and then move the bit back into the material, and then continue on. And there's nothing wrong with this. This makes very nice tabbing. The only thing to consider with this is that with all the starts and stops that X and Y axes on your machine have to make, it's going to take longer to process the file. However, if we use a V-tab configuration, the machine is always in motion. It never stops, and that can add significant time savings to your cut file. Doing 2 of these mini arrows on my MK2 machine, processing at like 400 inches a minute just to prove it, and then changing all the tabs to V tabs, I improved my time from, I want to say like 6 minutes down to about 4 minutes to cut 2 of these airplane kits out. So there's time savings there. One thing to consider, this is more of an advanced tab where we set our bit depth at 50% for tabbing. Here we would want to go to maybe 20% to leave more material. Just the nature of these tabs, if you don't leave a little bit more meat on your foam after you cut the tab, well then you're most likely going to have parts falling out of the sheet anyway, even though there's tabs there. So I wanted to let you know about that up front. That's something to certainly consider. For this exercise, we're going to use just our standard tabbing. So a little bit about tabbing here. Also, you have to take into consideration that we're tabbing only enough tabs to hold the parts into the sheet as it processes back and forth into our machine. So I find that leading edge, trailing edge tabs are much more important than side tabs. You still want to have some, but you need to have more on the leading edge. That's your biggest focus because, again, material's going back and forth in this direction. So with that being the case, I might elect to add a tab here and maybe one here and here. Maybe just one here. We'll put one here. And you'll see that as long as we have our tabbing tool activated, well then the tabs are showing up in a nice dark green. If I take that tool off, then they get real faint. You can still see them there, but they get real faint. But as long as we have our tab tool activated, they get strong, and that's good. That really helps you to see when you're tabbing. And I don't know who did this to the PhlatScript, but kudos to you. It really helps you to see. And I'll just continue adding on, and just to show you, this is all so easy to do. Now if you are working your file up and you go out and you cut it and you say, wow, you know, everything worked really well, except maybe this part over here fell out. Well, then you know maybe you need to go back and readdress how you've tabbed it. But I just add just a few here. We'll add them as such. Now I can tell you in other CAM programs are programs that help you to generate machine code. Nothing I have ever seen is as easy as doing machine code in the PhlatPrinter. It's just amazing. It works so well, and instead of using higher end solutions like I have for my big machine, my all aluminum overhead gantry machine, I find myself using the SketchUp and the PhlatScript more often than others. If I'm going to do just a real quick few parts, I won't even pull up Aspire. I will. Anyway, you kind of get an idea of what's going on. Now, in this case, I know with these that this gap here is a 1/4 inch or close enough to it. I don't bother putting tabs in these, because if I've got a 1/8 inch bit that's offset, by the time it makes the round, there's not enough material here to make a tab. So I don't bother with those so much. And that's pretty much, you know, how it's done. Now, I didn't do all the rest of these parts. I don't think it's necessary. But there are some other features of the PhlatScript that we'll talk about. Real quick, let's talk about the eraser tool. And this allows us to erase any flat edge that we maybe have a problem with. Like, let's say I want to redo, maybe I want to redo this one. Well, I can click on that, and that entire element is done. It's gone. And it allows me to go in and redo it, maybe if I had a mistake or something. So inside cut, hover in there, and we got it. So if you have maybe one tab that you say, I really wished I didn't put that one tab there, well, then I can use that tool and come over, and I should be able to get rid of that one tab and then place it somewhere else. I go back to the tab tool and so forth. Sometimes on some parts you're going to find, I think I saw one over here, you're going to find that sometimes your tab tool is not going to give you a full width tab. That happens a lot on arcs. And for instance, we know we have a 1/4 inch wide tab width, and this is demonstrating that. But when I come over here, if I wanted to put a tab there, I see that, well, that tab is not as long as the other one. In the case of arcs, that's real important, because sometimes you just don't have enough facets to do that, in which case you can go ahead and click on it and then maybe add another one right beside it. And the machine will treat that as one full tab, even though it's made of two smaller ones. So I think with that we will move on to the next. Let's say I've got this all ready to go. The next thing I may want to do is I may want to go ahead and export my PhlatCode. And that's a real simple operation. We simply take this green button, and that's kind of our output file. And if I click on that, I can output my PhlatCode. Now I'm in my folder. I showed you earlier how I do my hierarchy and my file structure. If I go over here, this is my mini arrow V2. I'll come over here to PhlatCodes, and I may elect to save it. And there we go. Just that quick, I've got machine code output. Now here is an example where I've taken all of our work from this side, and I simply selected all of it. Now, the way I did it, oh, I've got that grouped. I didn't mean to do that. Well, the way I've done it is I just selected, I triple clicked on everything. That allowed me to get the face, all of the lines, and then the third click allowed me to pick up the PhlatCode lines. And once I had them all selected, by holding down my shift key from the first part to the second, just kept my shift key down so I could select multiple items, I was able to bring all of that material over, use my rotate tool to rotate it 180 degrees, and then bring it into place here. And now I can cut out 2 airplanes on one sheet. But I wanted to take this opportunity to show you another plug-in. While after I generated all of my gCode, while I'm in the document, and I can do that again, I have it all set up, generate the gCode, go into my PhlatCodes folder, and I just say save. In this case, yeah, I want to replace it. It's output. Now I can go into plugins. You'll see I've got other plugins here. Pay no attention to those because the ones that I had you install are the only ones you need right now. But if I take this Plot gCode plugin and I click that, it's going to open up this really neat plugin program here that allows us to see how our machine is going to operate, how it's going to cut these files. Now, if we're using Mach 3, then you would be able to see this in Mach 3. You'd be able to import the PhlatCode into Mach 3, see it on the display, and you'd be able to double check your work. Well, let's say maybe you're using a different machine to run your CNC machine, maybe out in your workshop, but you're enjoying the nice air-conditioned or heated luxury of your living room to work up your codes. Well, this is a great plug-in to use because it allows us to check how everything is working for us. I can see here from looking at this, and I can use my scroll button on my mouse to scroll back and forth, but I can see that this being the point of origin for the bit where we call 0, the blue line indicates what we call rapids. In other words, bit movements, non-cutting bit movements from part to part. So we're going to come in, we're going to cut this part, and after it goes all the way around and cuts it, then it's going to retract the bit, go to this part, cut it out, retract the bit, high speed to the next part, and so forth. So if we wanted to make sure that our code came out as planned, we can actually see it here. Now, one of the things I don't like about this particular plug-in application is that you have to have a scroll wheel on your mouse that also has a button, because with this I can click on this button, my mouse has it, and I can rotate it, and I can get an idea of my tabs. I release it and scroll in. If I right click the mouse, left click the mouse, I can pan it. But we can see everything that's going on here. We can see all of our tabs have come out and they're all looking pretty good. And of course we have all of our PhlatCode here. And if you've ever wondered what PhlatCode looks like, now this is it. So this is all the machine commands for all the coordinates and when to retract Z and when to move X and Y and so forth. And this is our header information that automatically pulls in from our parameters window. And then if we'd have put in any additional information in that comment section, it would have shown here. But I thought I'd show you that because that gives you an opportunity to check to make sure everything is cutting as you expect it to cut. And this one appears to be. So that is gplot. And I just simply hit the X button to close it up. You're going to like this next tool that we have in the PhlatScript toolbox here. We're going to talk now about the fold tool. Let's say you have a piece of foam. If you ever tried to bend an extruded polystyrene sheet like Depron or fan fold foam or one of those, rigid foam sheets, you know that to bend that foam maybe back on itself for a KF step or to bend it 90 degrees for maybe you're making a three-dimensional shape box style fuselage, well, you know that you have to crease that foam. And it usually means using a straight edge and finding where you want it and then bearing down on it to really dent that foam to allow it to pull back. And then when you try to fold it over, there's still material there, and most often it wants to, tear the remaining foam on the back side. Well, the fold tool helps us in this endeavor. Perhaps we've got something like you see here, just a long strip, rectangular piece of foam. That's what we're representing here. And maybe right down the center, we want to crease it easily to fold it back on itself, fold it back, I don't know, maybe 90 degrees. Well, to do this, we're going to use our fold tool to instruct our machine to come in on this line and then enter in at X depth, X being whatever we prescribe, and remove material all along the center line of this mid part of the sheet. And in doing that, that's going to allow us to more easily fold the two remaining pieces of foam together without tearing out. Still, I would recommend putting a strip of tape on the opposite side of the cut down the sheet of foam, just to kind of beef it up on that back side, keep it from tearing. But by removing material, it's going to more easily facilitate the bending of this foam. And we can let our flat printer do that, and our PhlatScript help us with that. We select the foam icon there, and we have an ability now to remove material. Now, if you go over here to our depth percentage, I can toggle through 4 different preset cut depths just by hitting my D button on my keyboard, and those are 100, 25, 50, and 75. And those percentages are going to be percentages of the thickness of the foam as we have previously, specified in our parameters window. And you may recall I've set this thing up so that I'm cutting a 1/4 inch material. That's the substrate thickness that I'm using. So I can simply select by toggling through the D what percentage I want to remove of that foam, and then take my pointer down here, and you'll see that that line is going to highlight. Now, there are 2 different settings that I can use. I can either highlight the entire path, or I can actually tap my W button on my keyboard, and it's going to change. I believe the pink one, if I'm not mistaken, we'll have to look it up in the help section, but my pink one, I think, does not go all the way to the end. I think it stops short, whereas when I hit W while I'm highlighted, it goes red, and I think that one does go the full length. In other words, the center line of the bit comes right to the center of that cut there. Anyway, this is going to be a very useful tool for you to use. I've used it on occasion, and I'll show you some advanced uses of it also. But let's say we want to go, more depth. Maybe we don't want to go to a pre-described depth of 25, 50, 75, or 100%. Maybe we want to go, 80%, 85%. Let's use 85 for an example. If I hit D, type in 85, well, now I'm at 85%. So if I pop a line right there, right now, then I have an 85% pass. 85% of 1/4 inch is my depth that I'm going to plow right through this piece of material. And again, that's going to help us to fold it over, and it's a pretty useful tool. Now, where else might you use a tool like this? Well, I'm going to show you. A lot of the guys in the Flat Club have taken to making hinges much easier. Rather than separating maybe an elevator an elevator from a horizontal stabilizer, well, they leave it all intact, and they allow this fold tool to help them by digging out material at pre-prescribed depths to make a hinge. Then again, you're going to put a piece of tape down, but I'm going to show you how you can use this practically. I might decide, this is my little crude representation of elevators and a horizontal stabilizer, and I'm going to start on this side. It's a little easier to see. But maybe I want to set my fold tool, and I'm just going to use the default values. Again, I've showed you how you can experiment and use different depths of cut. But perhaps we want to do, I'm going to toggle over to 75%. And if we highlight this middle line and we click on that, now we've got a 75% cut right on the hinge line. Well, now maybe we want to change our depth cut now to 50%. So I've just toggled my D until I got depth percent, default 50%. And now maybe I'll come here and click this one and this one. Now we hit D again to take us up to 25. We hit this one and this one. Now what we've done, and I guess the easiest way to show you, zoom extents, and I can come in over here and show you, this would be a side profile of what we've done. I put the, I'm using a 1/8 inch bit, that's what I'm expecting, and this is representing the cross section of a 1/4 inch piece of fan fold foam. Well, the first pass is this center pass right here, and it made it at a 75% depth. And then I spaced that the next lines, all the lines are spaced 1/16 inch apart. And that yields, you know, half of the bit diameter, basically. So now I've got the bit coming in and cutting 50% depths, and then finally 75% depths. And then if you were to take and put a piece of tape right here onto that foam, and then you were to grab this elevator and flex it up and down, then you're going to have a nice live hinge there. So that's a neat tool that you can use for, yeah, for you know, making hinges with your CNC machine. And it's a very useful tool, and it's a very clever use of that tool. I really like that. Now, there's another tool that we're going to talk about, and this might, I don't know how often you might use this with airplanes, but if you're using your CNC machine for other projects, you might find it very useful. Let's say that I wanted to place, we'll pretend like this is not wing KF steps. This is just a piece of foam or a piece of wood that we have. Maybe we would like to have a hole, a plunged hole into this material. Maybe it's a piece of wood, we're wanting to mount it to something, we want to relieve a screw hole. Well, that's where we can use this center line tool. This is a very useful tool. And basically it's just a plunge. All it's going to do is where you put it, it's going to put down a plunge into, you know, and plunge a hole the same diameter as your bit diameter into your material. And a lot of the guys found that very useful. And what I might want to do is, let's say I draw myself, let's say a 5-inch line there, so I can go, I'm going to wait till it turns blue and give me my 5-inch. There we go. And I'm just going to draw a line down. Okay, now maybe I want to come over here and we'll draw a click. I'm just tracing the line until I hit 5 inches. And draw here. Maybe I wanted a hole to be drilled in this piece of material right here. Very cool. I can come over here and grab the center line tool, and it has a depth plunge default value of 100%. And I can come right here and I can just center on this cross section right there, and I click, and now my PhlatCode that's generated will instruct my bit to come to these coordinates and to simply plunge 100% through the material, a hole that is the diameter of that bit. So that's a very useful tool if you're looking at drilling precise holes or doing a pecking pattern, things like that. Maybe you'd want to use them for, I don't know, cooling holes in a firewall, something like that. So that is how you use those tools. In this example, I'm going to show you another neat feature of the PhlatScript. Now, perhaps you've worked up a design similar to the one that you see right here. This is the Lanzo bomber that we've looked at earlier. And on this particular design, we had planned to cut all of the pieces for this kit out of 6mm Depron. And given the size that Depron was available to us, we weren't dealing with a 2-foot by 4-foot area. We were dealing with significantly shorter. I think it was 39 inches long by 13 inches wide. So I had to lay all of my parts out to fit within those sheets. Well, what you see here is once I've taken the opportunity to work everything out, I've got, you may be able to tell from looking at this, but if this is my bounding box for my cutting area of 34 by 13, well then these parts are grouped what looks to be kind of similar there. Well, once you have all your parts all laid out and you're ready to start generating your gCodes, your FLAT-codes, well, we know that by going into the parameters window, as soon as we define the parameters and we hit OK, well, we get a box that's placed at the 0, 0 position. In other words, the bottom left-hand corner of the top right-hand quadrant. That's our 0 position on our sheet. Well, once we've laid all this out, wouldn't it be nice? We know we're going to have to generate 3 sets of flat code, sheet 1, sheet 2, sheet 3. Wouldn't it be nice if we didn't have to juggle all these parts around anymore and risk making a mistake or dropping something off or accidentally melding parts together? And that's what this next button is going to do. This is going to allow us to move our sheet size around. If I click on this and I bring it out here, you can see, perhaps on your display, you can see that I've got a little dotted line. And if I bring this over right into position for the sheet, put it wherever I want to, and that looks pretty good, and I click, well, now it's moved our box from this 0, 0 position up to this next position. And now I could generate my flat code for, say, sheet 2 without having to move any parts. It's going to take into consideration, remember our bounding box will only allow gCode, flat code, to be generated for the parts within this box. So then I might generate flat code Lanzo Bomber flat code sheet 2. And then I could do that same thing again by clicking on this button and doing the same thing for this sheet. I zoomed in too tight. And bring it into position. Click. Now it's going to, when I generate my code, it's only going to consider these parts within the bounding box. So it's just another neat feature of the FlatScript. So a couple of other, now you notice I've skipped over this. This is our center line tool for doing lines, for center lines. I'm not going to get into that right now. That tool was developed specifically for a more advanced plugin, being the unfold tool, which allowed you to work up 3-dimensional objects and then unfold them and then treat those scores within those unfolded elements. And I consider that more of an advanced feature, so we're not going to talk about it in this video series. We know that this is our button to generate our flat code. This button right here, if you click on this, it's going to open your web browser and take you right to the Flatboys website. So if you ever want to see what they've got going on or a link to the forum or anything like that, you can hit this button. The last button we're going to discuss is the question mark, and I wonder what that might be. Well, in this case, that's our help file. I'm going to go ahead and click that. It's going to open up my browser, and this is a very nice description. If you forget what tools do what, this is a nice description to tell you all about that. We've got our, our icon, what it is, what it does, and so forth. So I wanted to be sure and let you know that that is there. We have our context menu. So that's all the buttons. Now we have other buttons that we can use, well, other features that we can use, but we're going to, I'll show you them briefly. We're going to just kind of go over them lightly here, but here I'm zooming into some code. Maybe I would like to delete this one tab. I can tell by the color that that's a tab. Now I could go over here and grab my eraser tool and erase that one tab. Maybe I didn't like where it was. I wanted to reposition it. I found that it tended to break when it was processing through my flat printer. Maybe I found that all of these tabs I would like to replace, or maybe just the tabs on this side. I'm going to show you a cool feature here. If you select that one Maybe I want to delete this one too, which may be kind of hard for you to see. Well, I can hit my shift, hold my shift button down, and I can select this one. Now I've got two selected. Maybe I want to come over here and delete this one, and we end up replacing all three of those. Well, now that I have them all shift selected together, I can simply right click, and I come down here. There's all kinds of things that I can do, but if I come down here to flat edge, now I can erase selected flat edges. It's a cool feature. Click. Now those and those only are gone. You also notice that there were other things in there. I'll just select a line, flat edge, and I can flatten selected edges. This is a kind of a neat thing that the PhlatScript does. We can, flatten a design back, make sure everything is all down to the 0Z plane, and everything else is, I think, pretty self-explanatory. And if we need to, we can get into that in a more advanced video. But that pretty much sums up the PhlatScript, and it turns out that section of tutorials was more in depth than the rest of it. But you'll see here that we can do quite a lot, and without having to spend hundreds of dollars for a CAM solution, we can generate our FlatCodes, or gCodes as they're called, for our machining operations right from within SketchUp.